for SDG indicators that were submitted long after the SDG DSD was released. And now I give it to Harumi to continue.
Thank you so
Harumi?
much, Abdullah.
We cannot hear you.
Thank you so much.
Harumi, we cannot hear you.
Hello? Hello? Yes.
Yes.
Now I'm here. Thank you so much, Abdullah, and good morning, everyone who are present and connected to the meeting. As Abdullah was mentioning, we will cover very few examples. These are probably most of the most of the most difficult cases that we have received to model. And in these examples, you will see what Abdullah was just saying, that SDG data is really multidimensional and really heterogeneous, and sometimes it's quite difficult to model the data that we receive. So I will start with the first one, that is the counterpart reference area. And this was received about 2 years ago, or 1.5 years ago, under indicator 10C1, remittance cost as a proportion of the amount remitted. And this was received after the DSD was developed. The data shows corridors from with sending countries and the receiving countries, and then the data is the proportion of the cost of the amount remitted. So you can see here in the table a brief example of the data that we receive. So, for example, we have from Saudi Arabia, there is money that is sent to Sudan, and then we have the data for several years. We originally didn't have a counterpart. Any other indicator had this issue of having a counterpart reference area. So we had to explore options on how to model the data. And if you can please move to the next slide. So there were, we had two options. The first one was to use a composite breakdown. And the second option was to use the custom breakdown. And I will go through some of the advantages and disadvantages of using each of them. So with the composite breakdown, it seemed that it was going to be a cleaner approach, as all the codes would be reused. But at the same time, the number of the code list will be increased, and also the sparsity of the data cube will be also would be increasing. In this case, we would have to add all the countries to make sure that they are that all of them are visible, and also to be consistent. But as Abdullah was mentioning, adding the list of countries as counterpart reference area under the composite breakdown, it could create conflicts with the use of other breakdowns. The other option was to use the custom breakdown. In this case, there was no need to maintain a list of codes and the descriptions, and we would be able to use the codes that are on their composite breakdown, so there was not going to be any conflict of using any of the breakdowns in the code in other code list. But there was a big challenge, especially for users, and depending on the sending area, receiving countries might end up having different codes. And this would also change in different, in every reporting cycle or in different reporting cycles. So we had a very brief discussion with our subgroup, the SDG on SDMX working group, and originally we wanted to implement and use the custom breakdown. Please, next. However, when we were trying to implement this in our database, we found issues, and we were not really able to technically implement the custom breakdown as it was explained in the previous slide. So at the end, UNSD proposed to continue using the custom breakdown, but instead we would create a code list and map these codes to M49 code and the M49 codes classification. So this means that the code C484 would always be used for Mexico, and for example, C250 would always be used for France. We had to add many codes because we needed to cover all the codes under M49. So that meant that we needed 1,000 codes in custom breakdown. So we had to increase the codes under custom breakdown so that it would support not only the current but also other and custom codes under M49. And this approach, it made it easier because the same code for one country was always going to be the same, regardless of the sending country. And also, this could also be used for future indicators that could use also this breakdown. So this is the first example, and I would like to jump to another example where we received data for indicator 1141. This indicator refers to the total per capita expenditure on the preservation, protection, and conservation of all cultural and natural heritage by source of funding. So public, private, type of heritage, cultural and natural, and level of government. So you can see here the amount of breakdowns that we have and how heterogeneous is in terms of the disaggregations that we receive in this case. So just to summarize, the disaggregations that we received were by source of funding, which is public, private. We also had total. We had also data disaggregated by the type of heritage. In this case, is cultural and natural. And then we also had the level of government, which is national, regional, and local or municipal. So, and you can see there are so many disaggregations, so many breakdowns. And if you can please move to the next slide. We only received 96 observations in this case. And as you can see here, we didn't receive data for all the combinations of the dimension and values. So in this case, we had to assess whether what to do and which of the breakdowns to be added under composite breakdown and which ones would go in the name of the series. And in this case, we we try to reduce the number of series to be created under this indicator so that there is not that many series that have to be maintained. And then if you can please move to the next slide. We decided to use the level of the government and add those codes under the composite breakdown code list. And then all the other were used to identify the different data series. So for example, we have a series that identifies the expenditure on cultural and natural heritage for public expenditure. And as you can see, we have all the, under the series, we have all the possible combinations for the different breakdowns that we receive. And the data that is received, the data under the series is disaggregated by the type, the level of the government. So this example shows really how multidimensional the SDG data is and the issues that we received. We will go through two very short examples that are the last ones.
Harumi, if I may ask you to please watch the time.
Sure. Thank you. So this is these two examples are related to indicator 1671 B and C. It is referred to the proportion of the positions in national and local institutions, including the public service in this slide. So we got data disaggregated by age, sex, type of occupation, disability status, and one population group that is defined very specific for each country. Most of the breakdowns existed already in the DSD, so we were able to use those breakdowns for age, sex, the type of occupation, and the disability status. And we only had to add the population group under the composite breakdown. And the result was that we had only one series for this sub-indicator, 1671B. And then we received the data for 1671C, that is in this next slide, which is very similar, but it had an additional disaggregation, and it was the court. And we were able to reuse all the all the breakdowns, age, sex, type of occupation, disability status, and the population group that was added for the previous one. And then we decided to add the court level as part of the series to identify the series, the data series. Thank you so much, Abdullah. No, everyone.
Yeah, thank you. Thank you, Harumi. So what's the outtake? When you model SDG indicators with the global DSD, you need to make heavy use of mixed dimensions. And a new breakdown can find its way into, depending on the situation, into the composite breakdown or the custom breakdown or series. And in the case of highly disaggregated indicators, of which you have just seen a few, the decision on how exactly to model this, it can be very difficult to make and must weigh many factors. So then the question is, why use mixed dimensions, especially the wildcard dimensions, composite and custom breakdown? Well, they are used to keep the sparsity, dimensionality, and dimensionality manageable. What are the alternatives to using mixed dimensions? You can have a pure structure where every concept is pure and represents only one breakdown. No custom breakdown, no composite breakdown. In which case you'll have a data structure with 50, 60, 70 dimensions, which of course leads to a very sparse cube and it becomes difficult to manage. Alternatively, you can go parsimonious, right? So you can split your structure into multiple structures depending on dimensionality. This is the approach that was taken in European Census Hub. But then the European Census Hub has 62 data, or 64 data structures. And I assure you that if we offer that to the reporters, they would be completely confused, and that would impact our response rates quite adversely. Or you can go simple, which is the approach taken by the IMF in the case of the ECOFIN DSD, in which case you roll all the dimensions into one, and then of course you have a single code list with 60,000 entries, which is the case for the ECOFIN DSD. So, I mean, damned if you do, damned if you don't. You have to use the least, bad approach in this situation, which happens to be composite and custom breakdown from my point of view. And another problem that these wildcard dimensions address is disruption caused by changing dimensionality. The cost of adding a code to a code list or a group of codes to a code list is far lower compared to the disruption caused by adding dimensions to a data structure. However, I mean, as you have just seen, mixed dimensions are not, it's a workaround, but it's not ideal. They're difficult to use for the reporter, receiver, and user, in particular the composite breakdown and especially the custom breakdown, where essentially the semantic of the code is defined at runtime or at transmission time, which goes against, many of the data structure design principles. They're difficult to implement in dissemination platforms. So very difficult for dissemination. We need to use workarounds such as annotations, additional attributes to kind of make it presentable. The thing is, the SDG, yes, it's a particularly complex case, particularly highly dimensional and heterogeneous, but this is not an exception in demographic and social, especially in the social statistics. This is more of a rule than exception. And any attempt to establish data exchange in social statistics will run into the same issues. SDMX 3.0 will not address these particular issues. It's going to bring many benefits, including semantic versioning and code list inheritance, which will simplify SDG data exchange, but this particular issue will not be addressed. So what does need to be addressed? We need to improve support for highly multidimensional data sets, and we need to reduce disruption to data exchange, which is caused by updates to dimensionality. These issues are not unique to SDMX. If you designed a database for demographic or social statistics, I mean, like I designed the UN database for demographic and social statistics 15 years ago, I ran into exactly the same issues designing the database as you do designing the data structure definition. Essentially, I worked around that by having 4 composite breakdowns in the database. The difference is that the database is you own it, and it's under your control. Whereas a DSD, even if you own it, it is used by multiple counterparties, and you cannot impose your changes on them, many of which are very expensive. They will simply, refuse to report, or they will send you data in some kind of an alternative format. So these problems are not unique to SDMX. They are, I think, present in practically any data exchange initiative. So what can be done about this? Well, there could be several approaches. One is to introduce inheritance at the level of dimensional model. That is, to make DSD inherit not just the code list, but also, inherit from another data structure and, extend it by adding dimensions. This is one possible solution. Another approach that could possibly work, which actually we presented a paper on at the SDMX conference in 2009, would be to have basically sibling data structures managed as a whole. So sort of think of Eurostat Census Hub with its 62 structures. Right now it's 62 different universes. Well, bring them together and manage them as one multiverse, maybe even hide the underlying data flows and data structures from the user, make the mappings easier, make the updates to dimensionality less disruptive. Or maybe it's going to be something else. I don't know. This is, but what I see is that as we expand into social statistics, and as we expand into national data exchange, these issues are going to loom very large. And I think that maybe we need to start thinking about it now, how to address those issues. And that's all. Thank you.
Very much, Abdullah and Harumi. And now it's time that we see what kind of challenges you have faced. And now it's the time to launch actually our Mentimeter. I really hope that you were able to log in. And we have two questions, and it will be interesting to see what are your responses to them. So the first question, maybe we can start. We wait a bit for also that you try to log in and join us. So the first question is, do you have experience using wildcard dimensions such as composite breakdown and custom breakdown? So it will be interesting to see how many people actually have the same challenges as our colleagues in UNSD. So apparently the data that you're having is really very rich and with a lot of dimensionality. We see that actually more people here in the audience and the ones that are joining online, they do not really have used composite breakdowns and custom breakdowns. Maybe we wait a few more seconds.
Custom breakdown is part of macroeconomic statistic structures as well. So for global reporting, this is pretty common. This is not exotic. But it's interesting that the majority did not use that.
Well, it could be also the case that they're not aware that this dimension is actually part of the DSD as for the global DSDs, where we have custom breakdowns, but it's not used by the organizations, and maybe that's why we see here significantly a no answer. Maybe we start we stop maybe with this one, because I think that it's clear that the majority do not have experience with these dimensions. Maybe we go with the next question. So the next question is, do you believe that wildcard dimensions are an acceptable long-term workaround for complex data modeling issues? It seems quite unbalanced reply. Oh yes, is leading now. I know, Abdullah, maybe clarify wildcard dimensions again. I know in case some of the users did not pay attention.
Yes, it's the composite breakdown and custom breakdown. Again, these are not exotic. Composite breakdown is a merged code list. It's a mixed dimension where you have many breakdowns in the same code list. And custom breakdown is completely generic codes whose semantics are defined at transmission time instead of in the data structure. Okay, well, what I can see is that most people haven't used the wildcard dimensions and they're very enthusiastic about them.
Yes.
Well,
yes. Now we open the floor for questions. In case you have questions, I have already 2 questions, but let's see what the audience is thinking about the solution that the UNSD is using currently. Ricardo, please. Ricardo.
Yeah, thank you. Thank you for the presentation, Abdullah, Harumi. And regarding the Mentimeter exercise, yeah, I mean, it's not a good solution, but until somebody has something better, please don't say no, because there's no other. Although I'm optimistic that with SDMA 3.0 that there will be some new workarounds to implement. No, my question is regarding this example that Harumi showed, that you will be using, if I understood correctly, the M49 code list for the custom breakdown. That this mean that you will change also the labels, or only you will associate the codes of M49 for the generic code list of the custom breakdown?
Yeah, we're not changing the labels, obviously. We just assign, I mean, the M49 country code for France is 250, so we assign custom breakdown code C50. We use it for France, and we put France into the custom breakdown label. Yeah, so, but the point is that how else can you implement such an update as a counterpart reference area? This was the compromise that we took.
Thank you, Edgardo, for the question and for the answer, Abdullah. More questions? Maybe I have one question for you.
So thanks a lot for the presentation. Very, very interesting. So regarding the questions, so they're probably acceptable, I think, for reporting and collection and perhaps like processing. But for dissemination, do you think that they're acceptable? Because I guess they're quite hard to understand, and you know, for an end user who's not kind of too familiar with the data model, then you know, presenting them in a table, you know, it's an extra kind of level of understanding that they need to have about the data model, I think.
Two things regarding whether they're acceptable for data exchange. Well, I don't know. You saw the complexity of the data that we have to deal with. At one point, it may become so cumbersome that, you know, it will become so difficult to model using the SGGDSD that I don't know. So I'm not sure. I'm not 100% sure that they're acceptable. I mean, again, we're managing with the current version SDMX 2.1. 3.0 will make improvements, but it will not fully address this particular issue. Regarding dissemination, yeah, I mean, of course, they shouldn't be used for dissemination. But then the issue is, I'm thinking about reporters, especially the countries. If they use, I mean, the global data structure they map their indicator to the global data structure, right? And which is a big effort. And then they have to map it, maybe create an additional set of structures and do an additional set of mappings for dissemination. This is not something that reporters appreciate. They don't appreciate having to map the same data set again and again and again and again and again. And mapping is a big effort. This is my concern.
And I have one question, because maybe it's a bit detailed, maybe to Harumi. I was wondering, I didn't see that you use, for example, attributes for the custom breakdown. And usually, I think in the global DSD, we are having this attribute where the country actually defines the meaning of the code. This the first question. And the second question, I don't know whether you have looked recently in the global DSDs and the custom breakdown code list there. But it's being now abused, so it's used. Actually, it's very interesting because the solution that you give exactly solves the issue that currently we have. So we have the custom breakdown with the custom codes, but then suddenly now there are also normal breakdowns, like maintainable codes, which appear in this code list. So actually, the code list becomes a mixture, even a bigger mixture. It becomes a mixture between custom breakdown and the composite breakdown that you have now. And I'm just wondering whether you have this case, even though in your implementation, most probably it's, there is a borderline, and most probably you're governing that no pollution is done, further pollution in custom breakdown. But it's quite interesting.
Well, of course, we do have the attribute custom breakdown label, which is used to define the semantics of the code. Yeah, we definitely have that. As for abusing custom breakdown, I don't think we have that issue because I don't believe, Harumi, correct me if I'm wrong, I don't believe that at this time we are actually exchanging any data with custom breakdown. We are disseminating, yes, but incoming data, I don't think we have indicators with custom breakdown. Harumi, can you correct me if I'm wrong?
No, you're right. You're correct.
Yeah, so our pain is in the future, it's coming.
Any other question? Maybe we take one, or there are no questions in the room. And thank you very much, Abdullah and Harumi. It was very interesting. Thank you very much. And now we continue with the next presentation. And this will be Anastasia and Stefan. So we continue with the modeling part. The topic here is units of measure modeling and standardization of units of measure representation. And Anastasia Samsonova holds a master degree in informatics from the Tautech University, and she has more than 15 years experience in IT projects of different complexity. She has been practicing SDMX since 2016 and is currently doing SDMX data modeling at the .StatSuite migration consultancy work for the OECD Smart Data Practices team. Anastasia also helps other organizations with the SDMX data modeling questions and data migrations to the .StatSuite. She also conducts a lot of trainings and does user support around SDMX. And we have Stephen Creed from Statistics Canada. He works as a manager for the Center of Statistical and Data Standards, and he's joining us online. Since he joined Stat Canada in the late 90s, he has held a number of positions working on IT systems and architecture, covering many statistical domains such as business surveys and national accounts. He's a member of the SDMX Statistical Working Group, and he also has leads actually the Government and Canada Data Architecture and Reference Data Management Working Group. Thanks a lot, and the floor is yours, Anastasia and Stefan.
Thank you.
Thank you. Good morning, everyone.
Good morning, everyone. Can you hear me?
Yes, we can hear you. Can you hear us?
Yes. So I guess I can start.
Yes. It will be a joint presentation. Stefan, please, the floor is yours.
Thank you. Firstly, I think it's been a great pleasure for me to collaborate directly with Anastasia from the OECD for the content of this presentation, which really deals about modeling units of measures and also the standardization of the representation of the unit of measure. So what is the problem we're trying to resolve? Why is it so difficult to properly model and represent unit of measure within DSDs and tools? Should be a simple concept, right? As of today, we still don't have an official cross-domain code list to represent unit of measures. It becomes somewhat challenging to model our data structures with the notion of reusing consistent unit of measure codes or categories. So why is this important? Both our data modelers and data users are demanding clarity in this space. At Statistics Canada, we confronted this hurdle when we tried to model our Canadian energy statistics domain. So when we think about the relation to FAIR principles, FAIR data objects should be findable, accessible, interoperable, and reusable. When trying to achieve optimal interoperability, we need to elevate our expectations beyond the typical systems technical layers of interoperability. Very often, we only consider APIs and protocols when we talk about interoperability. In this case, we really need to focus on the semantic layer. So in other words, providing a common vocabulary and language for unit of measure. Next slide, please. So the current state at Statistics Canada zone. So within Statistics Canada, we have a comprehensive dissemination platform to release our statistical data. So we currently have about 5,000 active data tables, which are available to our users. About half of these tables are regularly updated. In total, we have close to 4 billion data points. That was back in 2021. So we just released a census this year, so I'm sure this number is quite high, much higher than what I'm describing. Our foundational data layer is built upon the notion of a meta model for observation, which just closely resembles the SDMX data model. So we have, I'm going to say, much more of a legacy meta model describing our statistics in terms of dissemination. One of the challenges that we have is even though the number of dimensions can change from one table to another, the number of attributes are very static within our context set in Canada. We have a mandatory unit of measure related information that can be tagged at the table level or at one of the dimensions. As you can see on the right side of the slide, I have a word cloud that illustrates the number of occurrences for each unit of measure category. So in reality, through time, we sort of lost a bit of the control over the number of elements that we have within the unit of measure code list. We currently have over 400 elements. In some cases, we have duplication of codes, but in general, we're trying to represent many concepts with the unit of measure concept. So as you can see, we have the base here within our unit of measure, and this sort of elevates the count of categories within a concept. Next slide, and I'll hand it over to Anastasia.
Yeah, in OECD, we're currently using the .stat v7, but we are planning the migration of the data by the end of the next year. So in the new .stat suite, we are planning to have a common code list with units of measure, because how it's currently represented, it's kind of a mess. It currently in the V7 unit of measure can be in different places, in different parts of the structures. It could be an indicator name. It's very common in current .stats, or it could be a dimension, or it could be stored in metadata, and sometimes it's both is displayed in both cases, in both places. We have at the moment we have the common code list that users can use, but it doesn't cover all the needs. And because of this, when new data sets are created or updated, then the data managers create their own units of measure that always don't follow the same coding pattern or labeling rules. And another issue that we have is that sometimes the units of measure that we have in the data are not specific enough. So we have ratios or percentages, but without specifying the percentage of what. So recently we have tried to harmonize this and to prepare the first version of the shared code list that can be used in the .stat suite. And in the following slides, we will present the issues that we discovered. But now I think it's time for another Mentimeter question. We would like to ask you how you manage units of measure in your organization. I just switch the question in the Mentimeter. We have 4 options here to choose from. Like we have a standard code list of units of measure used in the organization. We're in the process of standardizing units of measure in the organization. Data managers create units of measure according to their needs, and we do not have an agreed list of units or do not use units of measure. Looks almost the same numbers for having a standard code list and managing the units of measure by the data owners, which is quite interesting. We also have some answers that from where we see that units of measure are not used, so there is no agreed code list. Okay, maybe let's stop here. We can discuss the results after the presentation, and we move back to the slides, and afterwards we can have a discussion.
Perfect.
Definitely.
Thanks. So from an international perspective, we've looked at related standards in this space. We did not, however, find a standard that was directly representing unit of measure from a statistical data standpoint. So just a few definitions from Wikipedia. So the ISO 80,000, which is sort of the evolution of the ISO 1000 series, is an international standard introducing the International System of Quantities, ISQ. It was developed jointly by the International Organization for Standardization, the ISO, and the International Electrotechnical Commission, IEC. So either you see ISO 80,000 or IEC 80,000, it means the same thing. The Unified Code of Units of Measure is a system of codes for representing measurement units. Its primary purpose is machine-to-machine communication rather than communication between humans. So there seems to be great alignment between these two standards, and also with the HL 7 standard, which is a very mature standard within the health domain. So even though these standards are mostly geared towards science-based capabilities, they offer great guidelines and insight for representing statistical measures. So we really need to find better ways to align to these standards as much as possible. Next slide, please. So we also looked at what's happening within the SDMX artifact. So I did mention previously that we don't necessarily have a cross-domain code list for unit of measures. But what we've seen is many different domains that have their unit of measure code list. So we compared the unit of measures code lists from 4 different domains: national accounts, trade, SDG, and the labor domain. The good news, there's a lot of similarities between the different code lists. The not so good news is that we do have inconsistencies in some cases, and we'll go through a few examples later on in the presentation. What we've seen is that there seems to have been a common starting point in the past, possibly from the national accounts DSDs, which were probably like one of the first ones that I guess were developed. And then these copies were made and they were extended to meet the needs of the different domains. So although we haven't closely evaluated the alignment with international standards, we have also seen some key differences in terms of alignment to the UCOM or the ISO 80,000 standards themselves. Next slide. I think now we're back to another Mentimeter question.
Yeah, let's go back to Mentimeter, and the next question is now available answering. And we would like to know now what reference standards or agreed codes are used for the units of measure in your organization.
Very interesting results.
Indeed.
Glad to see we have alignment with the ISO sort of standard. So this is a great news. It's great. Maybe we can move on to the next slide. Okay, so we thought we could probably provide a few examples on the differences we have within the different DSDs. And it's actually very interesting. And so as you can see, if we talking days, you can see that there is similarities between the national accounts DSDs and the trade DSDs, but the labor DSD has a different code representing that. So officially, if you look at the UCOM standard, D would be sort of the category for days. When we're talking about meters, you can see differences between the national accounts and the trade DSD. Where it becomes interesting is when you look at square meters and cubic meters. So the official sort of way to represent square meters would be M2. And what makes it really interesting is the fact that, that there's different types of codes. I mean, some are code sensitive, some are case sensitive, some are case insensitive as well. So as you can see, the national accounts DSD in terms of cubic meters having M3, I think is a pretty great representation as opposed to the MTQ. But at the same time, when they're representing square meters, they have MQ, which is not necessarily sort of the recommended approach in this case. The interesting one about tons, and this is very interesting, and I see that there is differences not just in the codes, but also in the labeling itself. So typically a metric ton, which is should be labeled TONNES, and that what makes it different in terms of a ton TONS, which is more the, I'm going to say, the American / imperial type view of tons, and they don't weigh the same thing. So we're really not talking about the same thing. They're similar in certain ways, but they're not exactly the same. So this is where we really need to add clarity to our users in terms of understanding exactly what we're trying to represent in these cases. Maybe you can go on to the next slide.
Yeah, and it gets even more interesting when checking more complex codes and the codes that relate to national currency or domestic currency or local currency. It can be named in a different ways in different DSDs. And it may also have different codes, like, again, trade DSD and national accounts DSD have a common code XDC for domestic currency, but it also includes some additional details in the labeling. But in SDG DSD, it's, for example, CAR LCU for local currency, and labor DSD, it's just currency. And another quite common unit of measure, US dollar PPP converted, may also be coded in a different way and includes different details, like converted using purchasing power parities or constant PPP USD. So yeah, there are more differences in the codes, but these are like the most used codes where we think there could be an agreement on the common coding and also on the labeling. Then when it comes to derived codes, when several codes are included in one code to present a ratio or something, or the per codes, we can also see that in different DSDs, a different pattern is used for that. In trade DSD, national accounts DSD, again, we have a similar pattern _R for per codes, but in SDG DSD, it's per, and labor DSD, it's _. So again, it is not very consistent in different DSDs, and here we could have a common pattern for that. And in OECD, we try to always use just the _ without introducing additional codes between the original codes in the derived ones. Now quickly about the method that we use in OECD to define what is the goods unit of measure, especially in the derived codes. For that, we use the dimensional analysis, and we see what's the unit of measure in numerator and denominator, and based on this, define the unit of measure itself. We try to avoid units of measure that don't have real units, like pure number or ratio, and try to remodel them using a unit of measure that provides more details, like percentage of something. And we try to be more specific, like we don't use percentages, but we say it's percentage of population, percentage of active population, or percent of active population, the same subgroup depending on the data that we want to model. And here on this slide, there are some examples of the national accounts DSD units of measure where we had an issue when reusing them because they seem to combine different components of the unit of measure. Maybe for reporting purposes, it's fine, but for dissemination, when we have in a table something like euro ratio to gross value added, it doesn't seem to be very easy to understand. And in OECD codeless, we remodel those to have percentage of value added or something like this. And another example is exchange rates, where it combines different details in the unit of measure, while some parts of the unit of measure is not really like a unit of measure.
So the great thing is that we have opportunities on modeling, let's say, unit of measure, and we need to do this using multiple concepts. And we've been doing this in the past as well. Like there's a lot of DSDs that if you look at the national accounts DSD, I mean, they do have the base period, they do have the unit multiplier as well. So I think we've been doing a pretty good job from that perspective. But I think we need to go a bit further and really to add sort of I'd say the related concepts which will sort of be tied to the unit of measures. So it's almost like producing a framework of codeless and concepts in representing unit of measures moving forward. Next slide.
We go back to Mentimeter, and we would like to ask you, like, if we would like to split this unit of measure, which is one of the examples from the current OECD DOSTAT V7, how many unit of measure concepts you would identify in this one? I'll activate the next question. Okay, it's interesting feedback. Yeah, we can discuss later with all of those who answered free. What are the units of measure here, components of units of measure here? In your opinion, maybe let's go back to the slides and show you how we, in our understanding, it could be split into the unit of measure concepts. So yeah, this is the same example, and I could find at least 5 concepts here, which the unit of measure itself, US dollar, price base, which is constant prices, conversion type, which is PPP converted, base period 2015, and unit multiplier millions. So 5 altogether. But I'm wondering why most of the audience answered free. We can check this maybe a bit later when we have the discussion part. Another example, which is in National Accounts Index per capita, but in V7, DOSTAT V7 per hat index using current prices and current PPP, so OECD equals 100. So again, it could be split here into five parts, or even 6, because unit multiplier units is not shown here, but it could be as well part of the unit of measure. Another example coming from StatCan for household energy consumption in gigajoules. So here, like the main unit of measure would be joules, and we could introduce here unit prefix with giga, and unit multiplier again could be units, and per household energy consumption would be a rather indicator, measure, or variable, whatever. So now a short example how combined unit of measure can be displayed in the DOSTAT suite. There is a special feature for that that helps to visualize all the different components of the unit of measure. For example, the ones that you can see on the screen and the ones that we talked about before when splitting the unit of measure into components. So here is an example where we model all the concepts of the unit of measure separately. So we have the price base, we have adjustment, we have transformation, conversion type, and unit of measure, unit multiplier, and base period. And this is the default behavior in the DOSTAT suite. It combines some of them. It takes unit of measure, unit multiplier, and base period by default, and displays them in the combined unit of measure column. But all the rest is displayed separately in the columns, and maybe not very easy to understand, especially when we have some not applicable codes in most of the column cells. But with the help of unit measure concepts annotation, we can instruct the DOSTAT suite to display the components of unit of measure together. So this is an example where we provided the annotation with price-based currency, unit of measure conversion type, unit multiplier, adjustment, and transformation. And as you can see, we now have just one column when all of these are concatenated. There is a way to hide some units of measure that don't add additional details like units. We don't see them here, but they are present in the model. And non-seasonally adjusted data as well, it can be hidden from the display. And like this, we get much user-friendly display for the units of measure.
So moving forward, I think it's pretty clear that we need to start using multiple concepts or properly, I'd say, model unit of measures. I think the community has done really great work so far, and we just need to push the envelope a bit further. Adding clarity in terms of guidelines, best practices, playbooks is really important as well. We need to align as much as possible to international frameworks if possible. Since there are different ways of labeling unit of measures, we should ensure that we can capture these different ways within annotation as much as possible. Also, based on the release of yesterday of the forum, I think it's a great opportunity to even think about having a center of excellence type approach with our data modelers so that we can share insight and really work together to sort of resolve these types of challenges. The SWG must entertain the publication of an official cross-domain code list if possible for unit of measures. This may be challenging for the existing global DSDs, as they will be confronted to possibly a major revision, which is something when we try to release SDMX version 3, we may sort of want to coordinate as much as possible. Version 3 of SDMX can really help us in many ways. When we talk about inherited discriminated code lists, this feature I think will really help us sort of strike the right balance in terms of having a common code list for unit of measures, but also have the ability to extend for different domains. Health domain, energy domain, get into different types of measures that would really benefit from using proper unit of measures, but are really domain specific at this point. Also, the semantic versioning can really help us because as we're going to move forward, there'll be a lot of upgrades to these code lists until we reach that maturity moving forward. So having that, if there, let's say, changes that are minor or even patch type changes, then it should be a great way to not affect the systems that have references to them or DSTs that have references to them. So this pretty much, no, I think we have another slide.
It's not very, it's not about the units of measure, but it's a platform that OECD is developing and providing some materials on the data modeling and different materials on the DOSTA suite. So if you're interested in learning more about the DOSTA suite and how to model data in SDMX, we have several courses available and several courses are coming very soon. So please join us.
Thank you very much. It was quite an interesting presentation. Thank you, Anastasia and Stefan. So maybe we can a bit think about the results from the Mentimeter. And also in case you have questions in the audience. It was interesting. I think that, okay, maybe we can start here because I have the feeling that this is the most interesting slide where people were misled and picked up 3 actually components, and actually we had 5. So it's very difficult to slice down the different components and to see the idea why, for example, we have this information in the unit of measure. I know. If someone would like to ask a question, yes, Edgardo, go ahead.
Well, thank you for the presentation. It was very, very interesting, and I think that it gives a lot of material for the SWG to work. So, David, you have work ahead. Regarding that, I can explain my reasoning, my line of reasoning. One of the 20 in the red tag, but I understood reference year as time period, not base year. So it's a matter of language. So if reference year is reference period, it's not part of the unit of measure, of course. And we can debate a lot, but for me, the scale or unit multiplier is not part necessarily of the unit of measure. It's a different concept. But yeah, this is controversial. I would not enter into this. That's why, for me, the other 3 are clearly concepts of the unit of measure. The other point that I would like to put on the table to discuss is about unit of measure as a dimension or as an attribute, because it has maybe it's an endless discussion, but I think that is a crucial decision when you are doing the modeling. And in our approach, I say our because we have discussed extensively that in the team in the ILO, we prefer to try to use the unit of measure as an attribute and not to condition the model with the unit of measure as a dimension. And for example, this has an advantage that was in one slide that Stefan presented, that was multiple measures. That is something that is coming in HTML 3.0, and multiple measures may have or will have different unit of measures, and attributes can be attached at the measure level, but dimensions are common for the multiple measures. So having unit of measure as an attribute will allow you to have multiple measures with different unit of measures. What could not be possible if you have unit of measure as a dimension.
Maybe just comment on what you said. Based on, for example, our experience at the European Central Bank, unit of measure is used to accommodate a lot of derived data. So data which is actually not used for exchange but for dissemination. And we put there a lot of information coming from the formula. As statisticians, we want to tell the user actually how the ratio was calculated. And then usually you have this rule that you have, and I think in national accounts we use it, that the numerator is the for example, the unit, then the underscore R, and then everything that comes behind gets the denominator information. But sometimes this can be really overwhelming because you are trying to code a second series in the denominator, and then it can get really very complex. But I have the feeling that this unit of measure dimension sometimes is abused also to code things which actually maybe can be coded in a different way. Other questions? Yes.
So I think I echo what Edgardo said of the unit of measure, how it is looked at. So if you look at GDP and you try to create a DSD for it, you have like GDP as one dimension, current or constant as another one, and then the unit of measure becomes US dollar, and then the unit multiplier becomes millions or thousands or whatever the value is. So that's the reason why I think I took unit of measure as US dollar and not necessarily the millions out there. And but having said that, which is good for exchange of data where you need this amount of granularity, but when it comes to dissemination, and it's also a question to Abdullah since he's dealing with the SDG, DSD, you have like DSDs with like 10 dimensions, 15 dimensions. And if you have to form a query tool where users have to use your dimensions to query data, it means they're manipulating, or even like they're using an API to get a certain amount of data. They need to know the right combination of dimensions to get exactly what they need. So that's where I think combining this into constant US dollars, millions, constant US dollar millions or something makes a lot of sense from a dissemination perspective. So maybe we need to look at, we've been talking about this dissemination DSD for quite some time. So maybe we need a data exchange DSD and a dissemination DSD.
Thank you, Sid. Other questions? Go ahead.
Okay, thank you. So first of all, thanks very much for this presentation, for this work. I mean, in my view, unit of measure is, well, let me put it this way. I'm pretty sure that at the 16th SDMX experts meeting in 2032, we'll still be discussing unit of measure. It's an extremely complex topic. Just a few comments on the presentation. One is that it's very often very difficult to separate the unit of the measure from the indicator it applies to. It can be very, very difficult, and you can have multiple options, none of which is clearly better than another. That's one. Secondly, and thirdly, what impacts also this data modeling work is one, legacy. Many of the units that you see in the SDG TSD are legacy, and they go back to the MTT data structure definition, which was created in 2008. And two, common practice. Because you can have the most beautiful data model, but if this indicator is distributed, is disseminated customarily with the unit of measure of kilogram CO2 oil equivalent per unit of GDP in constant prices, I mean, you can slice and dice it any way you like, but if this is how the users are expecting this indicator, there isn't much you can do about this. So just a couple of comments on that. They're real. I mean, unfortunately, when we do data modeling, we have real life constraints, and I can go like that for years. But you know, these real life constraints have to be taken into account. Thanks.
Other questions? I saw some.
Yeah, hello, thanks. I find it funny that through the unit of measure discussion, we come back to dissemination DSDs, and I think if we have a topic to discuss over lunch, maybe Sid, because I object again to use different DSDs for dissemination. Just unit of measure presents a use case for that. But in dissemination, we have two basically main usages, right? One would be machine use, that you get something from the web service, and the other one maybe to present a nice table on a dashboard or whatever. But still, when we want to present a nice table and then the user downloads the data, they should get the full dimensionality, because if they want to process it further, they would need to normalize again to the original data model. And you create a lot of headache then mapping it back to the original data model. But for you is dissemination, for the next one is collection. So, if we see the whole value chain in terms of data value chain across all the organizations that would work with data, I don't think it's a good idea to have additional DSTs. It's maybe a better idea, but we'll discuss it, I think, tomorrow about improving the way we can automatically visualize even complex data in simple tables using kind of visualization topics. There is a beginning with annotations now, with controlled annotations where we can do some techniques to hide some dimensions from visualizations, but I would not use separate DSTs in the backend. It creates a mess in data processing.
Thank you, Daniel. Other questions in the room? Okay, thank you then, Anastasia and Stefan. It was a very interesting presentation, and we continue with the last one for the first part of this session. Here is David with the reference metadata modeling, migration and transformation using global metadata concept scheme. Quite interesting presentation around the metadata modeling. So David is a smart data practice manager at the OECD, leading the SDMX modeling team that remodeled the OECD statistical metadata using SDMX. He has been involved in IT system development for 30 years, most of the time in official statistics. Davis is the chair of the SDMX statistical working group, which maintains the content-oriented guidelines for the SDMX implementation and statistical modeling. And he's also a member of the Modern Stats Standards Working Group that maintains statistical modernization models for businesses and technical architecture. The floor is yours with this super interesting presentation on MSDs.
Okay, thank you very much for the introduction. So I guess this presentation is a little bit different because I'm going to talk about reference metadata and how the OECD has adopted the global metadata concept scheme for reference metadata, and how we're transforming our old reference metadata to this new concept scheme. So first of all, just a reminder on what the global metadata concept scheme is and what it's used for. So yeah, it was created in order to harmonize reference metadata concepts. So it serves as a controlled vocabulary to do that. And when we created it in the statistical working group, we actually had several people outside the working group participating in the project. And I think we used mainly Eurostat SIMS, IMF DCAF, and the OECD metadata scheme, just to make sure that we had everything relevant in it. So the concept scheme exists as first of all, as a guideline that you can find on sdmx.org, but it's also an actual concept scheme artifact in the global registry. So if you search for CS global metadata, you'll find it. And so it's a concept scheme. It's not an it's not a metadata structure definition itself, because the idea is it will be very difficult to think that every organization would have exactly the same metadata structure definition, and every domain would need the same MSD as well. So because it's a concept scheme, we can actually derive highly compatible MSDs from it. And the goal in having it is to boost reference metadata exchange, which is kind of very low at the moment. Hopefully growing. I mean, the SDGs is I think the first global metadata structure definition that was created, and it refers to the concept scheme. But also it's supposed to ease the management of reference metadata by reducing mappings between metadata concept schemes, and to have a non-ambiguous set of concepts, and so that users are kind of familiar with the same concepts. So this is like a picture on how it's supposed to reduce mapping. So before the metadata concept scheme, this is what you have on the left, where each organization maps to each other's metadata classifications. So you can see, you know, the OECD has to maintain a mapping for every other agency that it wants to exchange reference metadata with. And so does every other agency with every other agency. So, you know, you scale this up in terms of agencies, and then you have a big mess, basically. And the idea is to move to something like this on the right, where for exchange, each agency, rather than having to adopt the global metadata concept scheme, although of course it's easier if they do so, they map their internal classification to the global metadata concept scheme, and that's what they send to another agency. So each agency, in effect, just maps to and from the global metadata concept scheme for exchange, rather than having to map to everybody else's agency that they want to exchange with. And you can see that it really reduces the amount of mapping. So onto the OECD implementation of the concept scheme. So this is just a kind of partial table, and you probably can't see everything on it because the text is quite small, but just to give an idea of, oops. Yeah, so the middle pillar is our current classification, and there's 42 categories in it. And we're moving to the new global metadata concept scheme classification, which is on the right-hand side, which has about like 15 to 17 categories. And we can see that there's a big reduction in the number of categories, and there's a lot of kind of many-to-one mappings where several of our ambiguous categories which exist maps to a non-ambiguous category on the right-hand side. And some of these things also map to data attributes because they really belong in a DSD, such as unit of measure, unit multiplier, etc. Okay, so how are we going to do this, or when are we going to do this? Well, we're currently migrating all of our data from OECD.stat version 7 to .stat suite. So everything is going to be remodeled, all the data structures. And at the same time, of course, it's a very good opportunity to remodel the reference metadata as well. I mean, in case really we kind of have to do it because the attachments of the metadata to the new data structures have got to change anyway. So we may as well do it now. So how to do it? So we're moving from the previous data structure and the previous metadata concepts, those 42 fields we could see in the middle, and the attachment data coordinates. We do some magic, and then we come up with the new data structure and the new reference metadata concepts and data coordinates. So let's take a look at the magic part, because of course it's not magic. So this is the process that we're using to do this migration of the reference metadata. So first of all, a person has to create the structure map between the existing and the existing datasets in .stat version 7 and the new datasets in .stat suite. Okay, so this is in order to do the data transformation. And yeah, just say, and we do this using the Fusion metadata registry to create those structure maps and representation maps. And they're stored in .stat suite. So then we can use automation to get the existing reference metadata with the 42 categories from .stat, the old .stat version 7, just using SQL queries. And we have a process that will transform the existing reference metadata to the new concepts, to the concept scheme, which is compatible with the global metadata concept scheme. And then we transform the existing reference metadata coordinates to the new dataset coordinates. So these are already described in the structure maps and the representation maps. But because these are partial key mappings, because they're attaching the reference metadata to the data structure, we created a transformation service in Python to do this. So I'll talk about a little bit about that later on. But this can be automated. And then we need human intervention again to validate the transformed reference metadata and the coordinates, and perhaps edit it, because a lot of the metadata is like many-to-one mapping, so there's some concatenation automatically going on, and the human has to validate that. And then again, we can use automation to upload the transformed reference metadata to the new dataset in the .stat suite lifecycle manager, data lifecycle manager. So just a very quick look at the authoring mappings in the FMR. So here we have a structure map for a measure component, and we can see, a measure in the old data set is going to several components in the new data structure. And that's what the structure map does, and it refers to a representation map for the codes. So, and this is a representation map where we see, when the source measure is CAR, then that maps to several codes in the other code list. And basically, you can do the whole kind of mapping like this. So the Python service that we created to do the transformation. So yeah, as I said, I mean, the reason why we did this is because we needed partial key transformation, which isn't a part of the transformer in the FMR, and we couldn't find another one, so we created it. And it's a service which takes an SDMX CSV to transform, and a URN to a structure map like the one that I've just shown. So yeah, it's SDMX CSV2 because it's transforming reference metadata, and the structure map is SDMX3. So yeah, so you have to have like SDMX3 structure maps, but depending on the usage, maybe we can do some kind of upgrading of 2.1 structure sets. We'll see. It supports Open API, so it's compatible with Swagger. So it has like an easy interface out of the box. You can, automate the workflow, or we will automate the workflow by using Git runners. Regular expressions supported in transformations, like they're part of the SDMX3 structure maps, etc. And you can also use it for data transformation. Yep. So yeah, just coming to the end. So Pedro showed a little bit of this yesterday, but I just thought because it's relevant here. So for the reference metadata authoring, we have this component that's part of the .stat suite, the DLM Excel add-in. So what you do here is you, using the, once you've installed it, you go to the menu, you say, okay, get me the, for this data set, get me the reference metadata. So it's like a little wizard that comes up. And then this pulls in all of the metadata with the attachment coordinates here. So when you're authoring, first of all, you create the data coordinates that you want to create the reference metadata for. Then you click on Edit here. It'll take you into the metadata editor, which you can do kind of lots of nice things. It's really quite practical. So yeah, you edit it there, and you can have as many languages as you want here. And then when you've done it for as many coordinates as you want, either you can save the entire table that you have in Excel, or you can just highlight a few rows and say selected data, and this will save it directly into .stat suite. So the conclusions from this, well, metadata transformation can be automated because the main tools involved in this, they already existed, right? We're just kind of pulling them all together into a workflow, or to store things and create the structure maps. And the other bits were quite rapid to develop, like the thing that we use to validate the metadata coming from .stat version 7 took just a few days. The Python service took about a week so far. We're still putting the finishing touches to it. The partial key transformation is possible with the Python service, and it's needed for reference metadata. So we've got to have this. Excel can actually be a rich text authoring environment. I was skeptical at first, but they managed to do it, which is great. And SDMX CSV2 is really great for reference metadata. I mean, it's simple, it's easy to produce and exchange. So yeah, let's all use that. So that's it. Thank you very much.
Thank you, David. Now we have a few Mentimeter questions. I know that we are a bit running late for the coffee break, but I think it's good that we finish with your presentation, and afterwards we have 2 more presentations. So I think the time will be fitting up to lunchtime. So Tia will share with us the links. So how do you classify your reference metadata? So using the global metadata concept scheme, using the European SMS. No, for me it's very difficult to read. I know maybe you can read.
So using the global metadata concept scheme, using the European SIMS classification, using the IMF's GQAF classification, organization's internal classification, or other.
It's interesting to see that the majority are using their own classifications.
Yeah, I guess there's no surprise that there's so many using internal classification, but let's hope that the the blue bar goes up the next time we talk about this. So. Otherwise, I'll have to give the same presentation again. You'll all have to sit through it.
Maybe we can go to the next question. How does your organization transmit reference metadata? Using SDMX, using CSV, using Excel or Word, using PDF, other, and not transmitting reference metadata?
Yeah, I wonder what the other is. Is it like Word? No? Oh no, using Excel or Word is there. So
maybe sending emails. I don't know. It's interesting.
Yeah. If someone has an other, I'd be interested to know what it is. What? Okay.
Yes, indeed.
Okay.
Okay, I think that we can go with the next one. That's it. Okay, that was it. So questions for David. Reflection on the Mentimeter outcome.
Thank you. Yeah, thanks, David. I was interested to see in promoting kind of SDMX CSV as a great way to transmit reference metadata, because can't metadata get quite complicated with like HTML content and kind of quite lengthy text and presentational nodes and hierarchies? So do you see this in your CSV files, or is the metadata much more simple, just simple kind of flat concepts with simple content?
So far, yeah, I've had to deal with tables and lists, and I think that's been it so far. And yeah, the SDMX CSV seem to cope with that as long as you use the encoding, proper encoding. So so far it's been fine. But then as we move through the migration, I may have to like come back to your question and say, okay, well, it needs to kind of change or something. But so far it seems to be fine. But I mean, just to kind of fire it back to you, I mean, do you foresee a problem then?
I guess the metadata which we normally work with in the FMR is more attached to the level of the data flow and to structures. But from a kind of perspective of what information can go into the metadata, you can have obviously quite a lot of text. You can have HTML. You can have multiple occurrences of certain concepts. You can have trees of information. So the actual construct of the information can be quite complicated. And I kind of struggle to see how that then fits into a CSV file in such a neat way that it's sort of like the best way to transmit metadata. But I do agree that probably for the majority of use cases, that would be a very simple way to transmit the metadata.
Yeah, and I think that the metadata at the OECD is nothing out of the ordinary. I mean, I don't think we've got any kind of images or anything like that. It's, yeah, so far I don't foresee a problem, but we'll see, I guess.
Yeah, thank you. Thanks, David, for the presentation. Very interesting. Quick question. Are you waiting for SDMX 3.0 or are you rolling out right now? Because it seems that your use cases, in particular, the partial keys, they would normally be implemented as part of the TSD in SDMX 3.0. You wouldn't need an MSD for that. So are you waiting for 3.0 or are you proceeding in 2.1? Or are you planning to migrate to 3.0 later? Thank you.
So what I demoed in the process, I think the only part of it that is dependent on SDMX3 are the structure maps, the mapping, and SDMX CSV 2. Okay, so we've already implemented that in at least in .stat Suite, so it works for us there. So yeah, I don't think we're waiting on anything else in SDMX3, to implement it, because we've already done it. There's something we've got to see if we need to cope with 2.1 mappings, but that could be kind of retrofitted into the service, I think. So, yeah.
Yes, thank you. Thanks, David. That was really interesting. I just have a question on the validation side. So you have a CSV which embeds reference metadata. So do you use any validation specifically for the metadata, for the reference metadata in your data set?
Yeah, the validation that I mentioned was like a human validation. So it gets loaded into the .stat Suite DLM Excel adding, and then a human kind of looks at it and sees, because there's some concatenation going on between the many-to-one categories, the text. Then of course you can automate that, but it might look like crap at the end. So somebody's got to go through and maybe kind of change it a bit. So,
but just to follow up, so on the, for example, the coding that you have for the reference metadata attributes, you don't have already some validation in that context, or is it always free text? So
if you mean on the concept IDs, you mean?
I mean, if you're using a specific reference metadata attribute that is coded, if you're using the code list to validate that, for example, if you had the frequency as a reference metadata information, if you would.
What do you mean on the attachments? The attachment to the data structure, maybe?
No, on the values of the metadata attributes.
Yeah, I'm not sure. Maybe we'll follow up.
Yeah.
I think we're a bit late now. So
Thank you.
Yeah.
Other questions? If that's not the case, then a deserved break, and we take maybe 15 minutes. And we have 2 more presentations, so the second half will be shorter. Enjoy. What time is it? I just want to say what time we go back. Okay, then we go back at 11:10. Yeah, thank you.
We are about to start. We request the presence of the panelists on the stage, please. Can we ask for your attention, please, and come inside the room? We are about to start.
On modeling multi-source data and metadata for labor market information system. And here we have Edgardo and Shutong sharing the presentation. Edgardo Grising joined the IO in 2011, where he is a head knowledge management solution unit at the Department of Statistics. He has wide experience in statistical data processing, operation management, system administration, and business development. Prior joining ILO, he worked at the National Statistics Institute and the Social Development Ministry of Uruguay, and as a consultant for several international organizations in the field of statistical data processing and information system. He has additional experience in the private sector too, and since 2012, he participates in several committees and working groups for modernizing of official statistics, and he represents Iowa at the UN Geospatial Network and is currently the chair of the of SDMX Technical Working Group. Shutong Ding is Knowledge Management Officer also at the International Labour Organization, and he joined Iowa in 2015. And since then, he has worked on application development, portal maintenance, capacity building, and data innovations. He has developed many tools around SDMX to support the labor market information system. He also served as a data management specialist, providing technical support to implementing member states, assisting them with training exercises and workshops. Shu Tong has a PhD and master degree in statistics and bachelor degree in applied mathematics. Before joining ILO, he was a postdoctoral fellow and research engineer in Sweden. The floor is yours.
Thank you, Slatina. So, good morning again. The idea is in the next minutes, we are going to be telling you about our approach for data modeling in the implementation of labor market information system. So first, I will shortly try to describe what LMIS is. So please, Shu-Tong. And then explain the approach of data modeling we do. And Shu-Tong will do a quick demonstration of data modeling. And finally, some reflections about what is coming with SDMX 3.0 and how this will impact us. Labor market information system is a project that we have. It's a assistance that we provide to our member countries willing to implement an LMIS. We have developed certain methodology for the implementation. It is based on 4 components. The data, because of course without data there's no information system possible. A repository of information for what we use DOSTA suite. Then the capacity of analysis that the country must have in order to use this data, because the objective of LMIS is to monitor the evolution of the labor market and also to provide evidence for the formulation of labor policies and monitoring of labor policies. And the 4th component has to do with the institutional arrangements and the exchange of information. So today's presentation, of course, will be based on component 1, the data, and the transition of this data into the component 2, that is the repository, because this is where the data modeling takes place, because we have to collect data from multiple sources and put that in a format that is suitable with the repository of information that is DOSTA suite. So for that, we have a certain roadmap with different activities for building capacities at the national level, because of course that this is not an implementation that we do, but is an implementation that the country must do to make it sustainable. And you can see there different tracks that we have, and one of these tracks that is crucial is the data modeling track, where we provide an introduction to SDMX and data modeling. So what is the challenge here? One of the challenge here is that labor statistics come from multiple data sources, because probably you don't think of anything if I say labor statistics, but some of you probably think of a labor force survey. That is, of course, the main data source for labor statistics, but it's not the only one, and having a labor force survey is very important, but it's not enough to have a full characterization of the labor market. There's a number of other indicators, other statistical measures that come from other data sources like establishment surveys or administrative data, and more in the days that are coming or are already here from emerging data like big data or internet application, web scraping, etc. So all these data sources has to be put together in the repository of indicators that, as I already mentioned, is DOSTA suite, that you know is natively based in SDMX. So the process of ingesting all these different data types requires transformation, requires recoding, requires data modeling. And this is what we do in the process with the countries, building capacities in order to complete a process of go ahead, please, go quickly, because that allows us to have data that is what we call harmonized. That means that data can be comparable. And in this process of harmonization, we have discovered that SDMX is a great ally because it provides certain elements that helps a lot in the standardization and harmonization of data coming from multiple data sources. Number one characteristic of SDMX that helps in the data harmonization is the possibility of having a single concept scheme shared across the whole installation. So by having a single concept scheme with the set of concepts to be shared by any data that you are going to model, you are ensuring the unicity of concepts and definitions and unicity of classifications. Doesn't mean that you may need to have variants because things are not so perfect, especially when you talk about labor statistics. But at least you can have control of what the different concept really means. So the process of preparing the data starts always with microdata. Microdata, as you know, is information about the statistical unit. So this is information about the enterprises, about the people, about the households. But the source could be a survey or could be an administrative record. But this microdata has to go through a process of calculation of derived indicators. And this is the information that goes to the repository. So we are not talking about storing microdata in the LMIS. We are talking about having derived indicators like the unemployment rate, that this data will then be broken down by different criteria. These derived indicators sometimes are already published in the different stakeholders. So the National Statistical Office or the Ministry of Education already have indicators published. So this also generates another difficulty or another situation in which you may have data that come from microdata and you have to process, or data that is already in Excel or in PDF that is already published as derived indicator. So this requires a process of ETL, and of course that we do this ETL process based on DSDs. So the DSD is used as the formalization of the format that we want for the output data that will be then uploaded into the platform. For this, we have to go, of course, through the data modeling process before being able to upload the data and make it available through the DOSTAT suite. So what we are talking today is about data modeling, that this is main step there. What we have developed for data modeling is a toolkit. That is what Shuton will demonstrate you in a couple of minutes. We start by using a shared worksheet to collect the concept scheme. That shared concept scheme will be built in the process of data modeling from the different data sources and looking at what are the different indicators that wants to be displayed. Then we use SDMX constructor to generate all the structural metadata, and SMART for doing the data transformation. And finally, of course, DOSTA suite, that is the repository of indicators that we use. So just very briefly put it to run, what we do is to complete the cycle among the four components. So the different stakeholders produce data. This data is modeled and prepared for the ETL, for the upload into the DOSTA suite platform. Then this is made available to analysts in the component 3 that can use this data, of course, taking advantage of the interoperability that SDMX provides with different tools and languages. And then this information goes back to the same stakeholders that produce the data, but now as labor market harmonized information that can be used for policy making. So This was my brief introduction. Now I will let Shutong show you how.
Yes. So from here, I will try to explain our main implementation steps covering in the LMS. So basically, we have 3 phases in our implementations. And probably you already see some of this probably in Edgardo's slide, but it's a different angle. Here we have 3 phases. Start from the situation analyze, and we can see the dark blue color. We have highlighted those are the actions. And then we have also the olive green, that is the workshop, basically for capacity building. And then we have the light blue, where the outcomes from each. So here, the first phase is a situation analysis. We have try to analyze from the institution. We want to see who is the data provider, data user, and who is the key host. And then we have the track for the IT to define the system architect and try to install the platform. In the meantime, we can start with the statisticians and try to access the data availability and based on the outcome. And then we try to conduct the data production workshop, where we help the countries to produce those derived indicators from the microdata. And then we'll have 2 outcomes from the production workshop. The first one is the indicators that is produced from the microdata and can be saved in this Excel or CSV. And another outcome is the master plan, what is basically to describe all the potential indicators that can be collected, not only right now, but also long term. So we can have a clear picture that in long run, how many indicators we could collect for the market. And then we go to the second phase. So this is basically the focus of today is try to focus on the structured data modeling. And I will try to tackle more into this later on. And then the third phase is for the data preparation. So basically, once the structure is defined in your system, and we were using the data and also try to use the smart and to do the mapping and to prepare the data to upload to the .stat backend. So as I said, the focus here is the structure modeling, and I just want to also to maybe from a practical side and to share some of the experience we have found here. For example, we try to separate the roles for our member states. For example, we start with the preparation with all the concepts and the code list, and those tasks are defined mainly by statisticians and or the field experts, and they have the broad knowledge about the concept and the code list, and also how to define the desired tables that they want to present in their dissemination platform. So those conceptual work, we usually ask the statisticians to work on that, and then they can define them in the worksheets based on our template. And then we have also the data admin who can focus more and try to using the tools, and then they can have more trainings focused on the SDMX. So here we try to somehow have a separation of roles, and also we have the work can be done, and also for individuals. For example, when we create the concepts, we want to have a single entry for the concept scheme to guarantee that we have a harmonization for that. So this will be done by individuals, and then we also allow different institutions or member states try to commit their desired tables to be put on the system. So then this can be done jointly from different channels. So we also have worksheets that is for the statisticians, and then the XML it's more dedicated for the data admin. And of course, we have other, for example, the local or registry mode can allow them, if the system was not really established, we can start to work with the local mode. Now I'm jumping to let's say, the modeling sheets we have. And so here we have some kind of input data tables, just to show you some example. So we have the data tables, as the outcome from the data production workshop. And then we have the master plan. Also, it's in the worksheet. And then we have three basically modeling templates: the concept, the code list, and the tables. Of course, we have others, for example, the categories where we define the grouping of the tables. This is not shared here. Just try to focus on the key elements. And the key steps we have here is basically four. We start to validate whether we have a proper connection to the DLM backend. So we try to commit the agency scheme to the DLM backend. And then we start to prepare all this list of concepts and define their representations and creating concept scheme and the code list. And then we have to use, and I think I want to highlight that the third step is something that we try to create and try to minimize the efforts for the modeling, especially asking statisticians to really understand all the versioning and also the define a unique ID for them. It's very cumbersome. So here we try to sort of creating those DSD data flow and content constraint in single shot using a new feature that we have developed in the constructor called a table model. I will just demonstrate how this can be done. And then, of course, the last step is to organize the tables by topic or by themes that you would prefer and to create the category scheme. So these are basically the most important steps and the outcomes we have. And I want to switch to the demo. Let's first start with the worksheets, right? So we have let me share the link in the chat. So for all the colleagues here, probably it's easier for you to have a better view. So you can have the access to the Google Sheets. Here we have basically start from the first two parts. This is the data and the master plan. So we can see a typical data tables we have in the labor market. For example, we unemployment rate by sex and region. And then we have the table population outside labor force by sex and age. And then we also have, so you can have more, but this is just for some illustration purpose. And then we have the master plan, basically to define all the indicators and with the topic and also possible breakdowns that you can consider. So, and for example, the first one, the labor force participation rate, can be breakdown by sex, age, and geographic area, education level. But of course, you have to choose a good combination and breakdowns. You are not going to take all of them in single shot. You will end with a lot of sparsity in your table, right? So, and this is the master plan we have, and you can also, so it's a full list of the indicators and with all the possible breakdowns. And then we have the modeling sheets. Basically, we creating a certain, let's say, a template try to, let's say, for all the dimensions, for all the tables, we want to have the core dimension must be represented in the table. So we have reference area, frequency, and indicator. And then we have the breakdowns. Those are potentially optional, depends on how you want to break down the table. And then we have the time period, ops value, and all these. I think this is a typically you can see from many of the your table from your agency. So for the code list, we have also created, let's say, we don't want to separate them, but try to put everything in one sheet. So we create by the ID and also the name of the code list and the code and the name. And of course, we can allow multilingual for the code items. So here it's just the example and how we define those sheets. And the last one is the table. And we basically creating a structure to ask our colleagues in the country when they do the implementations and try to follow the same ID and And in this way, we want to have the control for all the entries. Let me just give you an example. So we see the table here. So for the table 1, that is the unemployment rate by sex and region. So for the statisticians, they still have to do the conceptual work. That is the unemployment rate. And suppose this is for the annual data, and then we have the breakdown, that is the sex. And the second part is the geographic coverage. So that's the geo. And based on your entry, and if you notice on the side, and we see there are some validations, they're creating the ID for you, and also the let's say the indicator name. So we try to avoid all those potential typos or mistakes, and try to rigid on that. And then the second one, it will be the population outside the labor force and by sex and age. So I will just quickly create that and population. So sex and age. And you can see in the template, we only allow up to 3 potential breakdowns. And you can also put the potential constraints as you wish. And you see here that the indicators plus the name are created in the table. So with all these conceptual notes, we're ready to use the tool and try to create all these elements. So let me quickly switch to the constructor. And so here in the constructor, I already tried to configure the connections to the DLM backend. So that is my connection string with all the connection entry points. And then you can see once I switch to my end, and I can see that there is an agency scheme, and I can load it here and go back to the DLM end. Let me just so in the DLM backend, and you can see this is the only artifacts I have. So that's the agency scheme. So I'm going to create the concepts and the co-lists based on that sheets, and we can bring it all into the system. So it's fairly straightforward. I have to go to the let's say start with the co-lists, and then I just have to select all the columns here. So I take a copy of that and I bring back to the tool here. And in the co-list, now I can do let's say a batch upload. So I can bring all the stuff and using the, let's say, more like a copy paste feature. Sorry, just let me restart again. So here, and you can see that I bring all the columns. Of course, you have to notice that we have to map the right columns to the right place. So for example, for the ID, I have all the co-list ID and the name and the co-list and the item. Once you have multilingual, you can append more, of course. And then here we can start with initiate the agency and version. So if you only have one agency and you don't want to specify different versions and so on, so just put just the one entry here and you load. And you can see we create all the co-list in single shot from a sheet. And now let me go to the concepts and the same procedure. So I go to the concepts part and then basically select the columns. Just want to. Yeah. The concept scheme, I can here basically try to delete the lines, and then I can load all these artifacts in here. So once I because the call list already saved in the cache. So now if the call list is properly referenced, and they can call the call list that is saved in the cache and try to load it here for you automatically. So based on those artifacts, and I just want to select all these concepts, and I select it to the concept pool here, and I start, let's say this one is for demo, and it's for, and change the agency, that is for the ILO, and then this is a demo example. Now I can switch the entry. I can push it this side or the artifacts and push it with all the descendants. And then this asking me with the basic credentials. So once I provide that, I will get all these artifacts is transmitting at the moment going to the DLM backend. So you can see that it's creating all these concepts and the call list in the system. So if I go back to the DLM backend, and now if I refresh that, just refresh the. We are reaching a timeout. So, and I can see my concept scheme. You can see it here. It's just created. So we bring the concept scheme and the call list. And I see the time is up. Let me quickly show the table modeler how we actually creating the 3 artifacts at the same time. So basically, I load all the concepts here, and I try to select, for example, the 3 core dimensions to the right place, and I know the reference area is for the entire country, and the frequency. So basically, here I'm assigning the constraints. So I want to put the constraint for those dimensions, and I know, for example, the first one is unemployment rate, and then I'm going for, let's say, time period. And here the table modeler is basically following a design of a representation of a table layout. So for example, the ops value goes to the core area where we have the value. Then we have the decimals, and on the ops value level, the ops status that is also here in the measure area. So basically, we say that those attributes are going to attach to the observation level. Then we have some of the attributes that goes to the food nodes. And now it's all left with the breakdowns. So if I respect the table there, I will have sex here, and then I have geo. And now I have all the elements putting on the table modeler. And then I can basically try to put the tag and the name, so I can take it from my sheets here. That's there. That is the place where prepare this. So, employment 1. That's the ID. Here I put it as a tag. Then where's the have the name? It's 1, and I put it here. And I specify the agency and the versions. Now I can push everything. So basically, this will create the 3 artifacts at the same time. So I just push it. And here we do some sort of compressing the dimension. I will not explain, but there are certain optimizations try to crashing the. For example, you have a data flow that is the unemployment rate by sex and geo, and then you have another data flow that the employment by sex and geo. They were shared with one DSP. Certain optimizations. Okay, so once I push that, and I had received a message, I go back to the DLM end, and we will find the data flow and vector. Now, if I now I can take over. Sorry, thank you. So for the data flow, if I just want to show you, for example, when we report the data, we have a structure view, give you the layout, and you can generate the CSV template, how you want to collect the data. Let me show you here, or generate on the table. It's done. So you will open the Excel sheets, and we can see the table layout. So here, this layout is following the new, let's say, SMS 2.0 CSV upload the template. So we give all the legitimate code or based on after the constraint. And then the users, for example, our reporting agency were able to generate those CSV following this format. And we're also providing the code lists for the users to understand what is the allowed code and what is the meaning of that. So basically, this is the collecting point for reporting the data and try to prepare if you know how to generate the CSV directly. Now I switch back to the slides and.
Yeah, in 30 seconds, because Latina is looking at me with anger. I just want to put some quick reflections of what will happen with that methodology when we have SDMX 3.0, something that is coming. And well, I just put some of the things that we have been looking at. And the first one is the availability of multiple measures in SDMX 3.0 will necessarily make us change our way of thinking, because we have internalized this measure dimension, this indirect reference to a measure dimension, because we need to put multiple measures in one single concept, that is the ops value. So this has become a natural way of thinking for those modeling in SDMX. But now with the multiple measures, we will have another possibilities that will certainly change our way of modeling the data. And this is not only for microdata, I mean, also for dissemination of derived indicators that will make a different approach. Then the extension of code list will provide a much more efficient way of dealing with the different variants. That is something that always generates a lot of work in order to specify constraints and properly switching between the different variants according to the context. The new structure maps will provide us with a lot of mapping capabilities for the recoding of the input data that, as I already explained, comes from different data sources. So imagine that in a country when you are mixing data from the National Statistical Office, the Ministry of Labor, the Ministry of Education, the same concept. You are lucky if the concept means exactly the same, but also it's impossible to have the same codes. So you have always need to create a new recoding mapping. Geospatial, that's a big question mark. We will have georeference data, how to deal with that, what will be the capabilities of the software to deal with that. The reference metadata. There will be, today we are not using reference metadata yet in our approach, except for very generic documentation, but I understand that there will be a critical decision at the data modeling time, that is, what is the criticality, what is the closeness of the metadata to the data. So in social statistics, there are some caveats that you have to give the user the information together with the data, because otherwise the user may misunderstand what is the figures are saying. So this type of footnotes, this type of information that is reference metadata must travel with the data. And if you put the reference metadata in MSDs, you are not, or in metadata flows, you are not sure that the user will see that, because that is not depending on the data modeler, but depending on the implementation and the use of the tool to display the data. So this is a critical decision that you have to take when you put the reference metadata in DSDs or in MSDs. Then the new multi-valued and measure attached attributes that will provide a new layer that actually I don't know how it will be displayed in 2D because the screens still have 2 dimensions. So you will have multiple dimensions in the table, but then you will have the attributes to the measures that is another layer. So it's a challenge for the tools developers. And finally, the semantic versioning and the new API capabilities, that also something that we will have to improve our model, our data model, to leverage these new possibilities that we still don't have. Probably there are much things to think of, but this is our short list. Pardon, I think. Well, hierarchy is good that we missed it. Thank you. I'm sorry for the time.
No, thank you very much. It was interesting to see this presentation because from the SWOT analysis yesterday, we saw that many participants said that we don't have tools for the analysis process. And here we see that you have, and it's quite interesting also, especially this optimization that you skipped a bit, how exactly you optimize. Anyway, are there questions from the audience? If not, maybe you can explain us about explain a bit about the optimization that you have. How do you decide, for example, how many DSDs you would like to have? And usually, on my side, I always think it's a business decision. Okay.
Yes, I would say that we still have. This is work in progress somehow because we want to improve that. But the idea is, first of all, the whole data modeler tries to hide the SDMX from the user. So we're trying to provide a tool that is intuitive and that the user just distribute the concepts in the layout of the table, and then they don't have to worry about DSD data flows or constraints that are generated automatically. And for the DSD, what we are doing is simply looking at the dimensionality of the data flow, and then we put the dimensions in alphabetical order because we rely on a single concept scheme. So we know that the concept appears only once. So we put all the dimensions in alphabetical order, and we see if there is already a DSD that has the same dimensionality or a superset of dimensions. And then we reuse this DSD. It's simple. It's not very magical.
But in case, for example, you have just one additional dimension, would you would you create a new DSD or?
Well, this is the next step. The idea is that if you find out that you have now a bigger DSD, the idea would be to change all the other data flows to point to this DSD and do all the data transformation. This is the work in progress, not yet ready.
More questions?
Thank you, Latina. Thank you, Edgardo, for a very interesting presentation, and thank you, Shutong. I mean, when I was looking at the table modeler, it struck me that maybe it's too easy to create a DSD. Maybe a lot of people will start using this, and you'll have a proliferation of DSD, and then you may end up in a DSD hell. Do you see this as a danger?
In an elegant way, I will say that this is a control risk, but yes, I agree with you, but this is only suitable for data dissemination. So this is a data dissemination system, and we are modeling data for data dissemination, not for data exchange. So if we are going to use a DSD for data collection, of course, that this requires a complete different process of data modeling, and I would use the SDMX matrix generator, for example, and it's a different approach. So for data dissemination, we understand that SDMX should be hidden from the users, and it doesn't matter if you have one DSD per data flow or I mean, it's something that actually the approach in Dostal Suite is to have one DSD for each data flow, and this is completely normal. I mean, there's no need to optimize. We are trying to optimize with this reutilization, but it's not really necessary. At least we haven't seen any performance issue on having multiple DSDs. And because it's a dissemination system, we don't expect maintenance of that. When you have the table tends to be stable. If you want to change the table, you will delete that and create another one. So it's not that you are going to be having this hard maintenance process that you have with the global DSD. But of course, that the table model is not for data exchange. That's for sure.
Sorry, just to make a small clarification that in .stat you can actually have one DSD and multiple data flows, or you can go for one DSD per data flow. So it's basically a modeling decision that's made.
Yeah.
And so just, sorry, maybe people were confused what you said because you said one DSD per data flow, but yeah, it's flexible enough to choose that. But maybe just a following point on that, I mean, not to steal the sort of discussion that will happen tomorrow, but I mean, talking about this sort of mess that could happen, I mean, this is really a governance question, and it's something that will be discussed, I think, tomorrow on XDMX governance, and how you actually impose or put that in place in your organization is very important, you know, whether it's a sort of inclusive model or it's a sort of centralized body that's managing that. So this is a very important question when we're talking about these tools and creating DSDs and things.
Just to clarify, I think that I did not express correctly. What I tried to say is that DOSTAT supports up to one DSD per data flow, and there have been no performance issue in this model that seems to be no optimal. But yes, we are actually trying to use less DSDs than data flows.
Yeah. First of all, congratulations. It's excellent work done. I just got a very generic question, like, Shitong, you gave such a good demo. So what kind of skill set is needed? Can you ask a statistician to do this? Or in general, if somebody has to do something like this, what kind of a skill set the person needs to do what has been done? Because it involves a combination of knowledge of statistical data, systems, and everything. So what kind of a skill set is needed for this kind of task to be done?
Perhaps I can. Yeah. So thank you. Actually, you already probably see in one of my slides that I mentioned that we have separate roles, and we actually try to keep the right profile for the right job. So basically, we try to let the statisticians focus on the harmonizations and to create the central call list and also one single concept scheme. And those has been done conceptually in a working sheets, right? So these will require all the statistical knowledge that you have in all the fields. And then we also try to somehow separate this from the data admin, where we say data admin can be a data engineer or more profile in the IT side. So they have a strong and good understanding of SDMX, so they can focus on to create all those artifacts and to ensure that they are valid based on the conceptual notes created in the worksheets. So for us, I think we sort of achieving this by separating them in different profiles and then let them to manage them separately. And definitely in terms of the capacity, we don't want to, let's say, put general requirements for a super data engineer understand all the statistics problems, which I don't think it's an easy task. Yeah.
Just a quick follow-up. So do you also need a person who is a translator between statistics and IT, or?
We always try to identify at least one person or one team that plays the role that we call the data manager. And this is normally a person that can be a statistician with IT skills or an IT person with basic statistical knowledge. It's a profile that is in between, and it's not easy to find. What we have seen with the experience is that we start with the data production workshop that is a pure statistical capacity building where the different stakeholder takes all the data available and try to define how to calculate indicators. So what we tell our counterparts in the countries put everybody in this workshop. The IT people, the users, the stakeholders, everybody goes there and everybody start getting the same information. And then for the next workshop, that is the SDMX, introduction to SDMX, again, we put everybody there, all the profiles. And now, naturally, you will see that at the end, there will be 1, 2, 3 people that gets the sense of what they have to do, and this is the right person for the role. And then from then on, normally this is the team that start working on the data transformation and data preparation. The main message is this is not an IT task, because also what we usually see is that at first they think, okay, this is for IT. No, this is not for IT. This is for statisticians, for economists, for analysts, but you will need some IT skills. Let's find which is the best person to do. Thanks.
No questions, so we can continue with the last presentation for the session.
Yeah, let's move on to the last presentation in the data modeling session, which will be done by Daniel Serrani. Daniel is in the SDMX field since more than 10 years when he joined Eurostat in 2009. He subsequently worked as coordinator for the first global DSD project on national accounts and was also responsible for its implementation in Eurostat. Since 3 years, Daniel works at the ECB and is now lead data architect in the ECB data office. His main responsibility is to develop and implement a common data architecture framework for the ECB in coordination with other central banks and partner organizations. So Daniel, the floor is yours. Please use 20 minutes for the presentation and 10 minutes for the questions so that we can finish on time.
Yes, thank you, Anastasia. I mean, I'm aware it's the last slot before lunch, and I take this responsibility very serious. But I nevertheless hope that I can also create some appetite for data modeling before we move on to real food. So do we have the slide also on the Teams now? Thank you. So basically, what is the business motivation behind? And thanks, Anastasia, for the introduction. So moving from a kind of concrete modeling challenge that we have heard so far in many of the use cases to a more abstract way to expand the use of SDMX in data modeling and in metadata management. And when we follow a bit the way data modeling best practices work or the way data models work, then what we start usually is with a logical data model, and we don't know that much in SDMX, but it's a more abstract way. And I just gave a simple example here from our world to say, for instance, a bank is an organization, a credit card is a financial instrument, and a bank issues a credit card to a person. That's quite simple. It's an abstract logical data model that usually we don't capture with SDMX because we want to collect maybe data on transactions, or we want to collect data on the different activities around this topic. So what we go for is an implementation of this logical data model to get data around this area, and then we create DSDs. And I think we all know now how to create DSDs, and we have heard many presentations about the challenges. But basically what you described then with the DSD are the different entities, dimensions and attributes of banks, of financial instruments, and then maybe also values for financial transactions that happen here in this triangle. So it's still quite simple, and this is the typical use case of SDMX where we sit now. So we have implementation models. They're independent of technology. They show kind of a breakdown of this logical world into concrete entities, and then typically we go down to the physical layer, so we store all that in databases. And of course, the great advantage of using an information model like SDMX here is that we are independent of the technology. So the same DSD you could store in relational tables, in Hadoop, and we will also see presentations about that from my colleagues, in XML files or wherever. So you're independent of the storage layer. And SDMX kind of today is building this bridge between the logical world and the storage world. It's also quite simple today, and we have many examples of tools where we can take SDMX and generate tables in a database. We can generate, for instance, SQL tables quite easily from the DSTs. We can populate it with data through the APIs. And then this database corresponds to the implementation layer of SDMX as well. So when you extract data, it's quite simple to map it back to DSTs. Where we have more challenges is here. So what we want, of course, is that these DSTs correspond to this higher level logical data model. We want to go back to that level. For instance, when we do data integration across many domains, when we want to do analytical tasks, usually it's not sufficient to be within the world of one DST or even a set of DSTs, but we need to go one level higher. And this is currently not really possible to generate. This is when you have the logical model in front of you. If you have one, you still need to remodel SDMX because the world looks quite different between logical and implementation layer. What we have investigated is, can we inject SDMX up here also in order to be able to do this link between the logical and the implementation world within one technology and giving us then all the advantages of the SDMX information model. So that we can close the circle here and also generate from logical models, let's say DST frameworks. The quick answer is yes. So there is an algorithmic approach we found. We use entities and relations, and we can store them in SDMX artifacts. And I will explain to you now in a high level what we did there in this project. And as data architects, of course, what we do is we stretch a bit the boundaries of SDMX. So what will be interesting then for the discussion later is, did we use SDMX or did we maybe misuse it? But I'm excited then to see with you how we can close this gap using our favorite standard in the room. So the way we created the proof of concept for this challenge, where the logical data model or entity relationship model design still happens outside. Of course, you have some modeling tools. It's not so relevant what you use, but what you will get as an output from there is a logical data model. So we start there. We don't model from the beginning in SDMX. We use standard data modeling tools. And then we try to define an algorithm to map this logical data model to SDMX artifacts, load it into the Fusion registry. And then in order to prove this concept, use the SDMX API and a simple transformation to get back to the graphical representation of the logical data model from the beginning. So if the picture at the end is the same as the picture in the beginning, then we know that we have everything we need within the SDMX artifacts in order to generate this model. So basically to say, if input matches output, then the SDMX in between is complete. So what we did, here's a kind of extraction of a logical data model from AnaCredit, which is one major use case in the ACB. You don't need to now read all the details. What you see on the graph is that we have, if you know the notation, basically we have different concrete and abstract entities. So not each of these entities will contain data. There's certain inheritance and certain tools used. So here we tried with a simple example to use most of the logical data modeling features. I will not dive in now, but simply focus on how we translated that to SDMX. So obviously, as most of you will have guessed, each of these entities would be represented with a DST. So also in the logical data model, each entity has kind of primary keys, has attributes, has measures, and this is quite simple to translate into a DST, including all the additional metadata we might have, like descriptions and names. SDMX is really strong there. The DST is the logical choice. The problem we have was with the relations. Of course, we have something in SDMX that can build relations, and we're using the structure map, which is used for different use cases, but we found out it has exactly all the things we need in the information model in order to put, of course, two DSTs in relation with each other. What the gap we had was the cardinality of the relation. And that is quite simple, because on the relation, you should simply put an annotation with the two different cardinalities. So without now going into detail what it means, but we have two use cases, either generalization or an end-to-end relation, and there can be different ones like 0 to 1, 1 to 1, and so on. If you know logical data modeling, or even sometimes in relational data modeling, this appears, and it's quite simple simply to stick that to the structure map and then say this DST relates to this other DST with this additional qualifier, and that way the relation is built and is modeled as well. So then, in order to manage it a bit simpler, is we put all the artifacts into a single category. with a category scheme. So basically, we have a category scheme. We create a category where we say this is the logical data model for HANA credit, and we create categorizations to all the DSTs and structure maps in order to bundle it. This is not needed, but it makes it easier to identify, to browse, and to manage later on, especially if later on you want to map this logical layer to the implementation layer. You can also then use a structure map to link the logical to the real DST, let's say. In some cases, they might be the same. So you might just reuse an entity in your DST. If they differ, you can use the structure map, or you could use additional kind of VTL to do the transformations in order to then also map data from the logical to the implementation layer. We did the POC in SDMX 2.1. So when you look at the details, there are some tricks that are being used. So the documentation is following SDMX 3, but the implementation is 2.1 because we didn't have the tools. So it's not completely clean, but the concept is there. So what was the output? Surprisingly enough, it was the same picture than the beginning, just without colors. We didn't model the colors in SDMX. But what we see there, and the POC code is available on GitHub if you want to look at it. What we did in order to go the way back was that we went to the SDMX API, basically go to the category, download all the artifacts that are categorized there. So then we get all the DSTs and relations, and then used a quite simple XSLT transformation. So there was not much programming needed, but a bit of understanding of XML, of course, in order to build a graph based on this SDMX artifacts. And this graph then can be visualized. It's a standard called graph with which can visualize using also this notation. And if you would compare the pictures, you would see that they contain the same information, including how the different artifacts are used, dimensions, attributes, including also versioning of SDMX 3. So to conclude, basically our business challenge was that could we save logical data models or entity relationship models in SDMX? I think a while ago the answer was no. Now the answer is yes. There are some caveats, and they could be interesting to discuss going forward. We have found an algorithmic approach, so we have some rules defined on how to translate that. We need some annotations, so not too many in that case. It's quite easy to control, and the way we put them was also kind of following the logic of the implementation model. So I think we did not misuse it too much, but they are there. And then there was one feature that we were missing in SDMX 3, which was DST with 0 dimensions. It has been discussed in the SDMX 3 working groups. The main use case for that was basically microdata and record-based data, where not always you have dimensionality. The feature was at the end not put there because of the effort of documentation and examples and so on. Basically, that's a feature that was promised for SDMX 3.1. If we don't have that, the trick we needed to use in the POC was to create an artificial dimension that didn't have any purpose in order just to have the artifact being maintainable in the Fusion registry. But yeah, so I was quite happy that we managed to do that. Just again, to summarize, it does not mean that we use SDMX really for the modeling of logical data models itself. There are many approaches, there are many tools. But what we want to achieve is that at the output of such a logical data modeling tool, we can go directly to Fusion and we can do the mapping within SDMX instead of creating complex mappings between different logical data modeling standards and then DSTs. So I'm not sure yet if we will bring it forward and how, but it was quite exciting to work on it, and it was quite exciting that it worked. We were more doubtful, but we were happy about the result. And with that, back to Slatina.
Questions?
Yeah, thanks very much, Daniel, for a very interesting presentation. Just to clarify something, so in the entity relationship diagram, you've got relationships between entities, and if each entity becomes a data structure definition, then in SDMX, each DSD is its own universe. You can only have indirect relationships between data structures based on, let's say, concept scheme. So in order to put those relationships in place, you used annotations. Is that correct?
The relation is a structure map, which basically creates a relation between two different DSTs, usually used to transform between two DSTs that would follow the same universe. In that case, we kind of misused it, but we had all the components there, so we could not talk about should we give it a different name, but it has all the attributes it needs from the information model in order to link to DSDs, and we needed the annotation to qualify that relation, to say it's not a simple relation between two DSDs, but it's one-to-many, it's many-to-one, or it's a generalization. So it's not only the annotation, it's an annotation on top of a structure map.
Oh, thanks very much. This really, I think it's really great to see. And why is because something which I think can be improved in SDMX is the complexity of mappings. And if you establish better relationships between, well, hypercubes within your domain or data structures or, data flows, then I think that there is a potential to significantly cut on the effort required for mappings. And I think that this is a step definitely in the right direction. Thank you.
Yeah, so thanks a lot, Daniel, for the presentation. Always very interesting. So the annotations that you use, I mean, of course, you can put whatever you want in an annotation, and describe, I guess, very complex things. So do you think that there would be some good candidates to add to the annotation control vocabulary that we have, as part of the SDMX guidelines? So.
Yeah, so definitely. So what I think where I copied some inspiration from was from the already guideline document we have now on annotations, where there's a controlled vocabulary for visualization of data flows. And I think it was mainly OECD driving that. And basically we followed that. So also we followed the logic. When you put the annotations in the solution proposal we followed the logic. What we found out there is that it's very quirky to use controlled annotations in terms of identifiers, in terms of what values can they take. So I think there's still a bit of work needed, and we improved it in SDMX 3. I still had to use 2.1 annotations there, so that's where some of the tricks happened. But the way controlled annotations are currently being used is not very user-friendly. So I think there's potential for that to create some kind of annotation packages like now we have for visualization. We would have here maybe one for entity relationship models. Where we can say if you want to extend SDMX for this specific use case, we don't always need to wait for the next version or create a specific artifact for it, but we could actually extend with annotations. I still think the word controlled is important because we should not create hundreds and thousands of annotations and everybody would have suddenly their own SDMX framework because they use annotations differently. But definitely, if this topic is interesting for the community, we would give that to the SWG what we have done, I think, could be quite quickly converted to a guideline plus the annotations. So I think that's one next step we could do to make that a kind of SWG guideline and say this is how you could model logical data models in SDMX.
Yeah, I think it could be really good because it will be good to have like another revision of the control vocabulary. There's things that we want to add to it as well. So it would be good to take the opportunity, with the work that you've done.
Thank you. Yes, it's a really interesting use case. But do you think that SDMX should be extended to natively model relational data?
I mean, my answer is yes. I think I gave it in the presentation, but I think there's discussion needed on where the boundaries are. I mean, this was a kind of more scientific approach to see can we do it and what would be the advantages if we do it. The advantage we saw was that we can do then data integration on the logical level through Fusion Registry as a backend tool. Fusion Registry doesn't have all the features, of course, in order to do then the real heavy lifting later on, but it's a first step in that direction. Where the boundaries are, I think that's something we can discuss in the community to say how far should we go. Like the boundaries we defined is let's not do the modeling using SDMX from the beginning because the logical data model users, they have their own universe, they have their own standards. Let's start when they are finished. Let's say that was for us the boundary in the proof of concept, but we can discuss. I think it's open. It's a new approach now. Should we do it? I believe we can. And then the question is where are the use cases, of course.
The questions? So some hands on this side, but I hope that they didn't get discouraged.
Maybe they got hungry.
Yes, maybe yes. So maybe we stop here and we wrap up for 30 seconds because I see that people are getting sleepy and hungry, so it's time to go out. So we learned a lot of things during this modeling session. I think that the word there was that was used in many of the presentation was multiple or multi. So we saw how to model multi-dimensional data, how to model multi-source data. We saw the multiple concept coverage of unit multipliers. So we saw also how to model reference metadata and logical data models. So I really hope that you get inspired and that you will optimize the way you model your data and learn from others, the ones that presented. So thank you very much. I thank a lot to the presenters and bon appetit.
Thanks for the participants who were part of the session number 3. We invite you to enjoy the meal that will take place at the garden area. We remind you that the session 4, Microdata, Big Data, Administrative Register Manager, will start at 2 o'clock. The participants are reminded to be at 1:55 here on stage. Please remind that you have your lunch passes at the back of the pads.
¿Me escuchas, Eric? Sí, creo que el problema es cuando están los dos al mismo tiempo, porque siempre como que queda, pero ya cuando están los dos al mismo tiempo como que se pelean entre ellos. Tanto el... Ah, ya, sí, va. Sí, sí, se escucha claro. Ahora sí se escucha nítido. Va, me desconecto.
kindly ask the panelists to come on the stage, please. We are about to start. Good afternoon. Now it's turn of session 4, Microdata, Big Data, Administrative Registers Management, organized by Almer Delic, Data Science Expert, ECV, and Stratos Nikoloutsos, Principal Software Engineer, BIS. Almer is currently working on a project to implement ECB's new statistical data production system based on big data technology. He maintains ECB's current statistical data production system and is responsible for managing ECB's function metadata registry. Stratos joined the BIS in 2021 after 15 years working on private sector on SDMX software, consulting and training. He has worked on SDMX related projects for BIS, Eurostat, OECD, and ECB, among other organizations. Member of the SDMX TWG for almost 10 years, and since September 2022, Stratos is the deputy chair of the SDMX Secretariat. Almer and Stratos, the floor is yours.
Hello, everyone. Welcome back after lunch to the afternoon session. I think yesterday we learned the afternoon session could be a bit challenging to stay alert. I think we have some interesting presentations that will hold your interest, I hope. The focus of this session is big data, microdata, administrative registers management, and then how SDMX is being used to process data and metadata in such scenarios, and the resulting challenges from such usages. We have 4 presentations in this session. 3 will be before the break and then 1 after. And we will have a 10-minute Q&A session after each presentation. And then also there is some time allocated after the presentation for further discussion and wrap up. The first presentation will be by Marja Jamsa. Marja Jamsa graduated from the University of Tartu in Estonia, majoring in informatics. She has followed several adult education and programming courses. Most of her career, she has been working in Statistics Estonia, first in recruiting and training interviewers and quality control, then in the Department for IT Development, where she was responsible for the dissemination applications. In 2021, Marja was seconded from Statistics Estonia as a national expert to Eurostat, where she's continuing her career in the data and metadata service team for SDMX implementation. Marja, please, you have the first presentation.
Thank you. First of all, I would like to say buenas tardes. I will talk about metadata for European microdata, and my presentation. Oh, here it is. My presentation I will first introduce microdata project, then how do we model microdata in SDMX version 2.1, what are the challenges there, and then how we are planning to model microdata in SDMX 3.0. Microdata project has come in live because as a Eurostat is responsible for provide efficient statistical system with member states, and users for Eurostat output include the Commission and the other institutions, European Union, national governments of member states, international organizations, businesses, universities, and wide range of other users. Metadata is essential to the usability of data. This is especially in the case of microdata. The current situation, what we have with metadata for microdata is that is all based in the documents. Documents are usually PDF documents or Word or Excel documents, and it's really hard to find a way around there because they are annual and they not describe systematically over the changes over the time. They describe data as it's received into Eurostat, not as a release for the users, and it's just domain specific. Purpose, the Eurostat aims to creating an effective and efficient metadata system that solves the issue. So the microdata, our ultimate objective for the project is create a metabase. It has a repository and also service of APIs, which makes the metadata accessible for the public in a standardized way. The system should allow to explore generated concepts like age, education, employment status, and domain specific variables across the following dimensions: domain or survey, time, level of anonymization, versions, country. On this first part, we actually this project started already 2020 with all the preparation work, and last year we actually moved to the next phase, which was anonymization for the DSDs. So here the DSDs that are on the first row with the different years, or we can say also waves for years. So these are US statistical on income and living conditions, labor force surveys, conduction of vocation and training survey, European health interview survey, harmonized European time use survey, and integrated farm survey. overview of proposal data model for metabase. So we have proposed a data model. This model's author is actually Luca Gramaglia. And for the model, we start anonymization with a DST. As a given wave, so as a given survey wave of SETA and SETA survey waves. So in a DST, you could have a different concept scheme. They could be combined in DST. On top of the DST, we have one data flow, but when we have a DST for all the years or waves the same, then we could have different data flows for different waves. Provisional agreement is linked for data flow and data provider. And when we anonymize DST or microdata, then we put the constraints on the data flow when it's a general, and also a provisional agreement when it's the country level. Provision agreements are provided for all the country level constraints. For example, some of the countries are so small that they are much stricter rules than other countries. For example, Malta or Luxembourg, or also I can say in Estonia, if you have a family with 12 kids, everybody knows who the family is. UI, or user interface for the metabase is actually on the process right now of doing it. So we have surveys for the researchers who would give their first opinion how they want this that metadata-based survey would be function. Then, so we are moving on to the microdata modeling. So in version 2.1, we have everybody here knows how to model aggregated data. So what we usually have, there is a lot of dimensions and attributes to describe primary measures. In microdata, we have the different situation. We have a lot of measures. So what we need to use, and therefore, actually in version 2.1, we already had a chance to use multiple measures, but our choice was not to choose that because there is not much support for IT tools. For example, our own Euro SDMX converter, SDMX-RI. There was no convertibility between versions 2.0 and 2.1. And measures cannot be declared as optional or mandatory, which is actually very useful for the microdata. I have an example of questionnaire. It's a gender-based violence questionnaire, and it's with answer with one respondent. As we can see in the respondent, line B14. So for the answers, there will always be some answers which are empty. So for example, when the respondent answered the questions like, are you married? Then he said like, no, then the next question can't be when you were married. So it's obviously have to be optional attribute. We can leave it empty. And the other way around as well, if you the question is, are you married? And they're like, no, well, yeah, well, yes, then you can't ask like, do you live with your partner? Because of course you live with your partner and you are married. But I know life is not so simple that, of course, there can be people who are married and live with a partner who are not married and so on. But we move here on. We got the values here for each question. We do have always the questions with the gray ones, which are leave empty, whichever path the respondent is going. And we do have variables. We have, and when we are modeling macro data, then we do have only few dimensions, which is primary key for us. We have a lot of attributes, because attributes we can both, is it optional or mandatory? And we don't use measure. Measure will leave empty. And if I show the same comparing with aggregated data, then we can see at aggregated data, there are a lot of dimensions, one measure, and not so many attributes. There, of course, can be a lot of attributes as well. And if you take a look at the age, income, and sex, they are, for age and income, there are a much difference. In dimension, they are code list, and in microdata, they are just the numbers. So there is the difference. What are the challenges of version 2.1? As everything is modeled as an attribute, the essential difference between the attributes and measures is lost in our model. So we really can't say which attribute goes to which measure, because they're all measures, they're all attributes, sorry. And therefore, we can't really use the flags. For example, information for income, we cannot link it. And observation value is not in use, so we don't use measure. But it's still there, and it's just not nice. When we start modeling SDMX 3.0, then what we could be different? We would definitely use many measures. This is an option over there, instead of the attributes. So attributes we can attach to the measures specifically, which is a new feature, measure relation. And in microdata, we often need specific values. For example, when you have income, and usually it's the number value 0 for billion, trillion, then we also use like values which mean something else, like -1 indicated, not stated. SDMX 3.0, there is a feature which is called sentinel values, which we can use. So just to visualize, so version 2.1, we were modeling all of the measures in the attributes. And for version 3.0, we can use measure for the real values and attach the attribute to the measure to link to the correct measure, as you can see with the arrow here. That was all. Thank you.
Are there any questions, please? Don't seem to be any questions. Maybe I can ask, did you actually, oh, sorry, I missed someone.
Yeah, thank you, Mario, for the presentation. The question I have is, have you tried or did you try to create a link between DDI and SDMX, or you didn't use DDI at all?
No, we didn't use DDI at all.
Do you think it's a promising direction of development?
Well, I have to say we haven't used DDI at all, so it's complicated.
you can hear me now. Okay. Just a question. I didn't see any tool mentioned, so I'm just interested to know what tool you're using to manage this and deal with it. So is it XDMX tool? Is it part of the Eurostat sort of tool suite? Is it open source? Is it available for others to use? Yeah.
For the anonymization project is led by external provider. And I have to say they have looked at different available tools. They mostly like David's metrics tool. And but they also using their own R programs to finalize the anonymization.
Yeah, thank you. Question, this issue of the ops value in SDMX 2.1, that yes, it has to be there. Have you evaluated the possibility of putting one measure there instead of leaving it empty?
No, I don't think we have tried to put it in one measure there. It's still more like mother-in-law gift, like you can't use it and you can't get rid of it. because
no,
because you can't put it mandatory way or optional, the measure.
Well, in a labor force survey or a household survey, there are always measures that are mandatory, but you can find one that is mandatory. My point is that the empty measure can be cumbersome, where depending the format you use, there are an old issue with the how to represent the null value in SDMX, and that's why I think that using the ops value at least for one measure could be safer in this regard.
Well, it might be, and but how we do with the big, which one is the best one to have a measure, real measure?
Each demographic one should be mandatory. Age, for example, sex probably are mandatory ones.
If I may respond to Edgardo, I think that it's a matter of semantics again. So if you are promoting one of them as a measure, then how do you know that the rest are measures or attributes? And I think this is where we're trying to get to with 3.0, because this was the uncertainty in 2.1. I mean, you could do it, but it would be only a practical approach, not really offering any semantics to your modeling. Yep.
Just sorry, another question. Did you experience any issues with like performance issues, the volumes of data you're dealing with in this process?
We haven't been in that stage that we would have these issues yet. We are just anonymizing those DSDs, and then we continue with the next steps. So there might be coming up.
Would have been also my question, but how much data do you have?
Well, we start with, I have to say, the simple one. So the DSDs that I showed, there are 6 surveys, and these 6 surveys have many waves, so different years. And those years are together 6 times, maybe 4 or 5. And these microdata for all the European members.
In the millions.
Or billions.
Thank you. Are there further questions? I don't see any hands.
This is a real question. I don't have an answer. Do you model the reference period as the time period I mentioned, or as an attribute?
It's usually dimension. At least we have modeled it as a dimension.
So you have exactly the same layout for all the years?
For the time dimension, yes.
No,
but
yeah.
No. The different waves have different concepts and different DSDs then, and because they have different models which are asked and which are not asked, and it will make it really complicated. So we can't use like one DSD and several data flows to relate to this one DSD. So pretty much every wave has their own DSD.
Exactly. So the time period will be mostly 1 year or different months or quarters. Thanks.
And when do you expect to start collecting and processing this data?
The data is actually collected, and we are just preparing all the metadata to be ready for researchers in this database. When this really happened, I really cannot say now.
Thanks a lot. Thank you.
So unless we have any more questions, I will take over to introduce Almir. Most likely you have already heard, listened to his bio, so the floor is yours, Almir, to tell us about the ECB.
Yes, thank you.
And big data.
So my presentation is about, we are implementing a new statistical data production system, and we have quite a large data set, and we faced a number of challenges processing this data, and I wanted to share with you what kind of challenges, how we solved them, how it all worked out. This first slide, it just shows you approximately how the system works, the architecture, and the rest of the presentation is also structured. It goes from collection, validations, aggregations to dissemination. So this is just to explain how it ties together, and then the rest will make more sense later. So collection, it's mostly based on Fusion registry for the validation, for conversions, and so on. I won't spend too much time on this because then the next slide explains the data pipeline in much more detail. How we store data is in HBase. We have multiple stages. We have reception where the data lands. Upon collection, then we have production where we promote data once we are sure it's of sufficient quality. We have 2 stages where we put collection, temporary and permanent collections, modifications and estimations is what we call them. Then we have a stage called compilation where we basically create the aggregates and so on. Then we have pre-dissemination. This is where we copy the data once the data producers are sure it's of sufficient quality for the last inspection. And then we have the actual dissemination stage, which we just keep to be able to create the deltas for different recipients. All of this is based on HBase. On top of HBase, we have what we call the data access layer, which is a Java web application, which we access via REST API. And this is the only way to access the data in HBase. You can only read or write through the data access layer, any application. So nothing accesses HBase directly to make sure the data is consistent. On top of this, we have what we call the common functions library, plus the calculation engine. This is written in mostly, so the vast majority of it is written in Python, but we have some things also written in R, like for the reports and so on, because of it's easier to format reports. And we also support all functionality also in R. So everything is implemented in Python. And then if you need to call the same function in R, we just have a very thin wrapper around the Python function. So we don't implement twice, we just wrap it. On top of this, how the users actually then interact with all of this is they use Jupyter Hub to run the Python code, to run the R code. We have RStudio, and then they're also able to run this on their laptop just using an IDE or something like this. And then on top of this, as the workflow scheduler and also the workflow manager, we have Camunda. So this is where we do all of the scheduling and all of the workflow, basically monitoring. And lastly, we have the web portal, which is just a very thin wrapper on Camunda functionalities. So this is where users will be able to monitor their ingestion, monitor the disseminations, be able to schedule new disseminations, and things like this. So this is how the architecture looks like. And then on the dissemination side, of course, once you're ready to send all of the data, we again have Fusion Registry, does all of the validations, all of the conversions, and so on. And in addition to this, we also support Parquet files, which we use for internal disseminations. So we will now go through the stages, because in each stage we faced different challenges. For collection, So this is how the data pipeline looks like in a little bit more detail. You can see it at the bottom. And our test case is one file with 1.6 million keys and about 5 million observations. So it's 3 observations per series key. The pipeline, we receive SDMX files, of course, they get validated by Fusion Registry. Then Fusion Registry converts everything for us to 2.1 ml. And then internally, we only need to support 2.1 ml. This is the advantage. So it doesn't matter if you receive JSMS or 2.0. Internally, we only process 2.1. And then the other thing that the Fusion Registry creates for us is the validation report. So what has failed validation, which observations are not allowed, which keys are not a part of the constraints, and so on. Then we have the component which is called CSDMX or Casper SDMX. What happens is that we take the file, take the 1.6 million keys, and we split it into observations, and they get put into Kafka. And Kafka, if you know, is just a messaging queue. So we put all of these observations into the messaging queue, then they get read by the data access layer, and data access layer starts writing to HBase. So this is it's a little bit, there are quite a few steps, but this is how the data pipeline works. And then the problem we had there is initially, so we rely on Fusion Registry for the validation and so on. And this part, as you see, was taking 12 minutes. Then we need just 2 minutes to put everything into Kafka. And then the biggest part of the processing was actually reading from Kafka. This was taking 18 minutes and writing it to HBase. And when we optimize things, what we do is we take a look at what's taking most of the time. And in our case, it was the writing. So we optimized this first. And how we did this is we first started batching observations. So not writing single observations, but batching them into groups. And then we also, what we did with the Kafka topic is we partitioned it into multiple partitions. And we created also multiple instances of the data access layer. So this means then at the same time, we can take multiple batches of observations and we can start writing them to HBase simultaneously. The nice thing about this is that, for instance, here you see we went from 18 minutes to 6 minutes. And the way we went there is basically we just created, we create 3 instances of the DAL, and this gives us the triple speed. So if you have files which are suddenly much larger, we can just create more instances of the data access layer. And this means we can write more data in parallel. So it gives us a very easy way to scale. This is one advantage of the architecture. We did have initially also, we were using NiFi in this architecture, but we were using it only to write the data, and we were basically maintaining a whole component just for this purpose. So we decided to remove it from the architecture and to basically just rely on the data access layer. So there is no more NiFi for us. There's nothing wrong with NiFi, it just was not working for our purposes. Next, once we have the data in your storage, what you want to do is you want to validate the data. And our largest data set at the moment, it has about 30 million keys. And you see below, we have various types of validations. So we have completeness, basic, critical, revision, outlier. And the initial numbers, the before numbers you see were, it was a little bit slow, especially grievous were the outliers with 14 hours. And what we did there is something we call, in the meantime, we call this a quick fix. Basically, we use multi-processing. So what this does is it's very similar to ingestion. We take, for instance, one type of checks, the completeness, we split it into groups of series keys. Then we create those batches and we distribute it across multiple cores. So Jupyter Hub has multiple cores. Every laptop has 8 or 12 cores. We split the batches and then we process them in parallel and then we put it back together. So this is a very, very cheap way to make something faster. It's a little bit cheating, but it does work. So the actual fix would be to optimize the code to run faster on one core. We also had to do input-output optimizations. This is where a big part of the slowdown was, reading the data and writing the data. And there we put a lot of work to basically be able to extract the data from HBase quickly. Just to mention, the one disadvantage of this multi-processing approach is it always works. But of course, when you're processing multiple batches, when you have 10 batches in parallel, you're losing a lot of memory. And so at the same time, when you want to do parallel processing, you have to make sure that everything is using a little bit less memory so that you can keep all of those in at the same time and calculate. And this is where the more efficient data structures come in. You have to watch, are you duplicating structures? Are you using the most efficient structures to store your data and so on? So this is what we did for validations. It's not the end of the road. We did this quick fix. Eventually, we will also completely rewrite how this works, so we don't need it. We have already done this for aggregations. Aggregations, it's similar. It's the same data set with about 30 million keys and observations. And the component which then does the calculations, we call it the calculation engine. And in this case, we calculate about 14 million keys or observations. So we produce about 14 million aggregates, which is not something we had before. So this is a completely new data set. So if you look at the before numbers, it says estimated because we don't know, because it never finished. So the most we managed to run this was for a couple of days, and then eventually something would fail, authentication would expire, some component would fail. So I think it was about a couple of days, but the estimated is between 3 and 5 days it would have taken. We've put in a huge amount of work to make this work because, of course, aggregations is the main part of the processing, is where we make the new data. And what we did is, you see here the numbers are split into the parts of the processing. So how much we spend in each portion. And for aggregations, the ingredients are, you need the formula expressions. So what are you calculating? You need the time series data, and then you need to calculate it, and then you need to write it. So it's not complicated, but it does take a lot of processing power. So what we did there is first we started using more efficient data structures, and because our processing is based on Python and on pandas, the main thing here was in pandas, it's a matter of using the correct data type. So we use a lot of categories because this saves us a lot of data. We use pi arrow strings instead of normal strings and things like this. So this reduces the memory usage. And then how we got from between 3 and 5 days to 0.3 minutes is by using NumPy and Numba. And we do this, Pandas basically supports this what's called the vectorized processing. And it means if you put a lot of data into Pandas in a certain way, and you ask Pandas to process it all together, it can do it very quickly. So we did this. Some things cannot be vectorized, but for this we use then Numba basically to run it on compiled code. And this now we're able to run in, so the calculations take only about 25 seconds to calculate all the 14 million aggregates. So we're quite proud of this achievement. So this helped us with NumPy and Numba for the processing speed, and then we still had to do a lot of improvements for the reading and for the writing, because also this in the beginning was taking a few hours, and now we're down to 14 minutes just to get the data, to get the 13 million, which is pretty fast, and then 10 million to write it. So this is also still a little bit in progress. We will still remove this, I think, 13 minutes for reading the actual formula expressions and so on, the graph with the calculations. So it should still get a bit faster, but this is now, it's good enough for our production purposes. It's fast enough to produce the data in a reasonable amount of time. Once you aggregate, of course, you want to disseminate the data. And this is then where we ran into the next problem. This is an example for 1 million keys and observations. And I will just briefly describe how the pipeline looks like again. We have Camunda, which is the workflow scheduler. So we run everything from Camunda. It goes via the data access layer. Then the next thing which happens is we have to attach the attributes, because when we create the aggregates, there are no series level attributes created. And this is where we have what we call the MAD tool. This was the first bottleneck. Then we create, of course, an SDMX file. And then if it's an internal dissemination, we also create a Parquet file. In both cases, we send the SDMX file to Fusion Registry to validate it, to make sure that everything is correct. It's according to the DSD, it's respecting the constraints and so on. And then if we disseminate the Parquet file, we just discard the SDMX. If we disseminate the SDMX, of course, we keep it. That's how the pipeline looks like. So before, estimated 40 hours. Again, we don't know. And after the optimizations, it was it's about 1 hour. So it's not the end of the road, but this gives us enough performance that we can disseminate the data in a reasonable amount of time. What we did was initially we were using Hive queries to manipulate Parquet files. Now we skipped this altogether because it was very slow to do it this way. Now we use a Java library which basically writes Parquet files directly and makes sure to update everything. And this is now a matter of minutes to update each Parquet file. And then also what we did before is we were using batches and then running queries after each single batch via Hive. And this we don't do anymore because the more data we disseminate, the slower it was to query the data again after every batch. And then what we did for the metadata attribute definition, which is again where we attached all the series level attributes like the titles, the unit measure, and so on. We did what we call the quick fix via multiprocessing. So we just split it into batches. We run across multiple cores, and this gives us a very cheap way to make improvements. So what did we learn from all of this? I think we learned quite a lot because we ran into so many issues in each step of the way. And I think everyone who starts working with microdata, with big data, is probably going to face similar issues. What we saw is that it's best always to look at all of the components from top to bottom. And we optimize first where we can gain basically the largest gain for the performance. So if there is one part which is disproportionately slow, this is what we optimize first. How we do this is, it's maybe obvious, but you have to profile the code. Because initially what happens is you ask a developer, the code is slow, you ask them to optimize, and they will look at the code and see something that looks suspicious to them and optimize this. But most often, this is not the part which is actually slow. So you have to profile, you have to see exactly which part is causing the slowdown, and then you start from there. And this actually we formalized. We now have for performance profiling, we use PySpy, and for memory, we use memory to understand where are we losing performance and memory. The other thing is we process now large groups of data because initially when we had this developed by the contractor, everything was being done naturally. You program everything to be processed key by key by key by key, and this is very slow. It's the easiest to program, but slow. Now what we do is we put keys into large data frames and then we process everything at once, and this gives us both memory and processing improvements. Do not be afraid to remove components. This is mainly about NiFi. We kept NiFi, I think, for too long. We didn't need it so long, but we didn't want to change the architecture. But in the end, we realized it's just not useful. We don't need it anymore. Consider performance from beginning to avoid rewriting is an ideal case. It doesn't always work. And one thing that helps here is not only to consider it, but to have people who actually know how to write performant code. This it's not a skill that every developer has, and we have 110 developers. When we have only one small team which is able to do this. So what we do now is we have lessons learned, and then developers share with the rest of the team what they learned and how they can write performant code. So we don't end up having one team write slow code and then the other team improving it, which is what we have to some degree now. What we do also is we use stream processing wherever possible. This turned out to be especially useful because our data model is based on JSON. So what used to happen is we would load, for instance, for the 30 million case, we would load the JSON file, which holds all the 30 million keys and observations. And at the same time, we would have to convert it to a data frame, which means for at least a moment, you have to hold both of those in memory, which is basically doubles the amount. And with stream processing, we just process each observation as it comes in. So this saves us a lot of memory. Appropriate data structure, this we covered a little bit. It's mostly about Python pandas because pandas is what we use for the processing. And reuse solutions where it makes sense is, I think the most obvious example is this multiprocessing. This is a very quick way, and it's in the beginning when we started, we didn't really have any developers who could do this. And then once we started learning, and you have a couple of developers who know how to do it, then basically they can apply the same solution to the other issues you have. So when you face the same problem elsewhere, they're able to do this on the other component. This is my last slide. If you have any questions.
So yeah, we'll take some questions. I saw Matt, also Petro. Yeah. So who gets the mic first?
Yeah. Have you seen an opportunity here to introduce a new format of SDMX, for example, in Parquet? Because I know this is a highly compressed file where you can distribute to other people. Whereas right now, if we want to share a large amount of data, it has to be CSV, XML, or JSON.
For dissemination purposes, or?
Yes, for the dissemination purposes, and also storing this data in a way that you don't need to have a web service, a database that has to be running constantly, and you can use this without expending energy, for example. And also you can just share the file afterwards.
We use Parquet for internal dissemination. So we have a Hadoop cluster, and then on top of it, we can run queries via Hive, and this we disseminate in Parquet format internally. So for internal users, because they can access, but we also have external customers like all of the national central banks, the BIS and Eurostat and so on, and they don't want to, of course, receive Parquet files from us. So for them, we create SDMX files, and this is what we disseminate. I think if we were to go this way, we would probably do something more like we would still create Parquet files, but we would just give them access to our system instead of sending them the Parquet files. So I think if it was to happen, it would be more like this than actual dissemination. And it would also be kind of shortcutting the SDMX format, which I'm sure would make very many people in this room unhappy. So we won't do this.
Thanks, Pedro. Matt? Yeah.
Yeah, thanks. It's more of a contribution, I think, to your presentation, because we made some modifications as well to Fusion on the performance, and I think the maintenance side, which was something I kind of wish we did before SDMX3, because I think it's a really useful addition on the content constraint, where when you're constraining series, you basically can define each series. But if you're constraining millions of series, then you have huge constraints in the registry. So of course, this takes up more memory, and there's more maintenance effort. But you can actually collapse these constraints. If you actually say, I'm going to list my series key, but when I get to the country dimension, I can actually put a plus between the countries. So maybe it's UK plus FR plus D, and maybe it's for multiple frequencies as well. And we made this change to Fusion to support this, and I think it's a really good addition, and I kind of wished it went into the SDMX 3.0 model, because we've had other users with very similar use cases. So yeah, I just want to mention that.
We have this already. So we have this because I think this is where we got, one of the times we got into trouble is, and I like the way you call it, was big metadata, because we were storing millions of keys for the constraints. And then things just slowed down to a crawl and started crashing. We were using all the memory, and then you gave us an update, and now I think we needed a couple of updates, then also one on the validation speed, but now since then we haven't faced any issues. So thanks a lot for that. Thank you.
So we have already proposals for 2 changes for SDMX 3.1, right? Yes, Rafael, please.
Yeah, so I'm first congratulations to those great optimization achievements. I guess it was quite frustrating if you realize that the aggregation workflow did not finish in time, timeouts, etc. I mean, can imagine how you felt it. So pretty impressive. Thanks a lot. I have a few questions. First, just following up on Pedro's question, did you actually compare, the compressed XML file, the sizes against Parquet? Is there would there be a big difference or not? Just out of interest?
We tried both, but I don't remember the numbers. We tried both for different purposes. We haven't tried it to compare between the two, because I don't think we have a similar use case. So what we have for compressed XML is we have a new EXDI flow. So when someone wants to send us data, mainly the NCBs or also Eurostat, now we have a compressed flow. And if they want to send us a file which has 30 million keys, they can compress it, send us the zip, and then we can unpack on our side. So this is something, and this is, I think, about 10-fold compression usually. It's quite useful.
Yeah, exactly. I mean, the compression is extremely good for XML files. So I was just wondering. Yeah, a few questions I have. So first, why are you not using Spark in one of your? I mean, that would be the natural candidate to speed things up. Have you considered it, or why is it not? Or has it been disregarded? And my second question is, you said that Hive is actually pretty slow in writing the Parquet files. I was actually surprised. Yeah, do you know what the reason was for this? Can we learn something out of this? And my third question. So you said that you discontinued NiFi, but the strength of NiFi is actually that it also supports this multiprocessing. Yeah, and what were the reasons why you actually discontinued NiFi? If you could elaborate a little bit on this. And then finally, my last question for the end users when they do the analysis. You said that they can use different environments, R, etc. Do they actually process data then on the client, or do you have a server based strategy for them to process data? Thanks.
Let's give you some time to
Thank you.
prepare for your 4 answers.
Okay,
In the meantime, anyone preparing to get the microphone next? Okay. Okay, so please.
I can maybe start backwards. So the last question was, is the data process on the client? It depends. If it's on Jupyter Hub, it runs on the, so it runs on the edge nodes, basically. We have Hadoop, and then we have a bit of space to scale up, but it depends because also the memory is shared. So you cannot have many clients using 30 gigs of memory each. We have to balance this a little bit. But it's quite useful, of course, because then the users, they can run aggregations, they can leave the office and they can come back tomorrow and they have the results. This is one way. The other way is via Camunda. So Camunda also has its own workers, and you can also start up the workers and you let them run, and this can also run in parallel. So I think at the moment we have only 5, but it gives us a way to scale horizontally. So we can have 20 workers, and then usually what we do is, ideally we would have 27 when we want to produce aggregations, and then we can run for each country on a separate worker, and this way it also gives us an easy way to parallelize. So this is 2 ways to run it on a remote server, and then of course you can just pip install all the libraries in Python and you can run it on your laptop. But of course, if you shut it down, if you close anything, it stops working. Why no Spark? We have Spark, but we're not using it and we prefer not to use it. And if you look at our numbers, we have about 30 million keys at the moment. They're not really Spark numbers. And the other thing is to implement something in Spark, you have to program it in a different way. There's also, it takes a little bit of time for Spark to start up. I think it's about 20 seconds the last time we used. So for small aggregations, the startup time is actually longer than the processing time. It doesn't make much sense. And most of our library at the moment, it's in Python, and we would like to keep it in Python. So we want everything to be done in the same way. So at the moment, there's no use case. If we really have to, we will go Spark. So we have it, it's integrated, then we will use it. But again, we prefer not to. NiFi discontinued. So NiFi, we were using it for 2 things. One is to write the data to HBase. And then the other one is we basically have this component which we call the SMS, which is the structural metadata service. It's basically a copy of Fusion Registry. So what we didn't want to do is have everything which needs a code list, which needs to visualize the data, contact the Fusion Registry. It would be a little bit too much load. So we have this service which serves this purpose. And in the end, we decided for these 2 things, we kept running into issues with too many file handles open. We had to tweak the configurations, how many threads, how many writers, and so on. And we said, okay, it's not really worth the effort. It was more about the effort than about anything being wrong with NiFi. Initially, I think the prototype was to use NiFi as the kind of the overall orchestrator, but we didn't go this way. Then it would make sense, but for this, it doesn't make too much sense. It's just not worth it. Why Hive was slow is, I think what they were doing is they were running queries. So they would send a batch of data, then they would query to see what's there. And then this is how they were used to update by using queries. And this was then very slow because the first batch is fast. The second batch is half the speed and so on. It becomes incrementally, the more data you have, the slower the queries become. So this wasn't the useful way to do it. And then now we just use a Java library and we just manipulate the files directly. So we don't query anything. I think those were the 4.
Thank you.
Thank you.
So, yes, I see Pedro.
Yeah, just to answer your question, we actually compare using a column stored format, which is Spark is one of those. You say DSD, which had 4 dimensions, the measure and 3 attributes with 70 million observations. And normally it took around 4.5 gigabytes to be stored. And in this format, it took around 400 megabytes. Not in Parquet, but in the same style of storing. So yeah, but other similar formats.
Thank you, Pedro. Edgardo.
Yeah, thanks. One short question. I would like to understand a bit better this. You have a step in the calculation, I think in the aggregation, that says that you add the metadata attributes or something like this.
This is for dissemination.
Yes. My question is, what are these attributes? Because, and I ask you because in the calculation process, in our calculation process, that is far from having the millions of cases you have, and is based on calculating some derived indicator from aggregate data, already aggregate data. Anyway, the calculation of attributes sometimes is the result of the operation. So these are observation level flags that you have to have into account. Or when you process microdata, sometimes you have some flags that are related to the amount of cases or the characteristic, the quality of the original data. So how you can disconnect that from the calculation?
It's attributes at two levels. One is at observation level, which of course we have the confidentiality and the status. And then for this, mostly we use defaults, and then we also have a component which deals with confidentiality. And then the other ones are at the series level. And this component that I was describing now, this was about the series level attributes. Because for dissemination, collection, it's not TST compliant. We never receive series level attributes. But then for dissemination, we want to disseminate the series level attributes, which means at some point we have to attach them. And then when you aggregate, you just have the values. There's nothing else. So we attach the observation level attributes first, and then there's a component which, based on some rules, there's a whole syntax. We have a syntax, and then users can define if it's this country, if it's that country, on certain rules. You attach this title, and then this runs, and it attaches the title to each series, and then this is what we disseminate. So this is completely separate from the aggregations. It's just titles, unit measures, and things like this.
Okay, thank you. Any more questions? Please, Glenn.
Unless I missed it, I didn't see VTL as part of the architecture. Was that considered and discounted, or what did you go for Python and pandas straight off?
Say again, what?
I didn't see VTL as part of the architecture.
VTL.
Was that considered and discounted?
It was considered indeed. So we looked at it for validations, mostly. For aggregations, we didn't. It's still limited. So we have quite complex aggregations. We have functions which manipulate also the index, the values. Also for validations, we have functions which cannot be. So I think probably 80% we could do with VTL, the simple ones. But then we would have to have some data sets which are only DTL, some which are mixed VTL and Python, some which are only Python, and we didn't want to have this. So now we have one component where we define basically the rules which run the validations, which run the aggregations in Python. And it's the same for everything. And the way we thought about this was the advantage is then you have users from one business area, you have users from another business area, and they can also support each other. Whereas if one business area uses VTL and another one doesn't, they can't really help each other. So this is also one big, it's a big deal for us, the support. We are still open to VTL if there's an extension, let's say, of the language of the expressions, but at the moment it's not enough.
Okay, thank you. Any more questions? I have one question myself, just to put this in the context of the experts group. I mean, this is quite impressive, and also the numbers are quite impressive, but maybe what we could have an idea is about your 3.0 plans. Because for now, I think everything is 2.1, but have you considered 3.0 landscape in your implementation?
We had conversations about it. We don't have a use case, so we don't want to implement something without the use case. It's basically no one wants to send us 3.0 and no one wants to receive 3.0 from us. So until this happens, probably we wouldn't go there. I think the first component we will update will be the Fusion registry. I expect sometimes after we wrap up mostly the project, which is next summer, then we can update to the latest Fusion registry, which then supports 3.0, so we can at least ingest data and disseminate and so on. I understood that this is a little bit risky, the update. It's not clear if you can reverse. There are quite significant changes also to the data model, to the database model. So we would like to push this a little bit further back, because basically for us, there's no pressure to move to 3.0. Things Latin agrees. The other thing is, so this is the easy part, will be to update the Fusion registry, but then of course there's the rest of the system. The database model is easy because it's JSON, so we can just add more data into it. We can add multi-measures and so on. So this is fairly easy. But everything else which is on top, which runs the Python, all of the services, aggregations, all of this will need to be updated to support multiple measures. I like to think it won't be too hard because it's just more values, but we'll see. But that's the plan, earliest in the summer Fusion registry, and then we see, unless there's suddenly a pressure, someone needs it, 3.0.
Right, thank you. I think we're done. Thank you very much for this presentation, and go on.
I think yours is the next one. Please, I want to introduce you. Please go ahead.
Okay. Okay, thank you. So in this presentation, we will not go into too many technical details as Medal has been introduced in the past. So it's mostly an update just to refresh your memory. And I'll have a few bullets of what Medal is, but essentially Medal and Medal managed specifically as is the part that is more important in that context is our consolidated data integration layer. So this is of course under development. That's why we are providing somehow a progress report here. So a few highlights and of what actually Medal is. So of course it's part of our BIS 2025 strategy. And the main capabilities is the data ingestion. So getting data from different data sources. And of course, there is a diverse group of data sources. So I mean, SDMX might be even not close to some of the data sources we are dealing with. Then the lossless data archival. So we have in all phases and in all processing that is performed, we keep all the data. So the raw data as they come in, the transform data based on the mappings and so on, everything is kept. And that's why we call it a lossless. And then the data normalization part, of course, validation based on the metadata that we have built our data collections upon, and mappings, because as we said, we collect from data sources that might not be relevant to SDMX, and then we have to go through some steps to transform them to, first of all, to something that is closer to an SDMX model, and at the second level, in many cases, closer to our internal data dictionary, so the proper harmonized codings and the proper model as we expect it to be in order to have, in the end, comparable data set across all our data. And finally, the data integration. So I think the key here is the time travel. So the user should be able to travel back on the different data submissions to see what has changed throughout time. And this is also key to the Medal processes. So some key characteristics, of course, it's metadata driven, is based on SDMX information model. And we will see, of course, that it started with 2.1, but currently I think that 99% is 3.0. And then it's based, it's resilient in terms that it's based on an infrastructure. So at the infrastructure level, uses some big data technologies. So distributed storage and processing. We will not see too many details, but of course, we're happy to discuss more if needed. So main components, we're still holding on Apache NiFi. In our case, it's actually the coordinator. So it coordinates all the flow of data. And yeah, this works well, at least for now. For the storage, we use different, I mean, HDFS is the main storage, so everything is a file essentially. And also Apache Hive and Delta Lake. So of course, there are other different experimentations I think we do for accessing the data, but yeah, this is the main infrastructure involved. And then we also use Apache Spark for processing. And of course, all these are currently under development. It's nothing, it's not in production yet. We're struggling to get it into production soon. And finally, I think a core component of this architecture is the Fusion product. So the FMR, mainly because all the infrastructure is driven by metadata, and all this metadata is stored in the FMR, and is not only the metadata that you would expect, so DSD's code list. So we have additional metadata, but maybe I can give you an idea of them. And of course, we have the SDMX library. So this essentially is the core of the FMR, if you will. So services that are used directly by the by MEDL, for example, for transformations, validations, and so on. Now let's see a bit what metadata we mean here. So of course, we have 3.0 structures, and in that case, of course, DSDs is the first thing that we use, but we also use it for building our physical model, because this is the model that the data will be stored in. So everything is done on the DSD, and then this is transformed into the physical model, as well as the Avro schemas that we have in our Cloudera schema registry. Then we have provisioning metadata, so all the relevant metadata for setting up a flow, so data flows, provision agreements, providers, and so on. And this is actually used to build our HDFS layout. So how this if I could say, the directories are structured, and all the structure of the HDFS is driven by this provisioning metadata. So we don't build it in advance. Then we have our agency schemes, of course, also used for permission and then actual authorization. We have metadata reports and metadata sets. And in this case, we're not talking about collecting reference metadata. So in the context of MEDL, we use it mainly for configuration. So this is configuring our NiFi processors and configuring different aspects of the processes. So for example, you could think of coding our errors. So in case of something, when something goes wrong, there is a code list supporting the different the coding scheme supporting the errors, the reported errors. We also have configuration about what the user prefers to do in his specific flow. So for example, what happens when a specific error occurs. So should I store the data set? Should I inform the user and store the data set? Should I not store the data set and only inform the users, and different things like that that actually control the flow? All those are part of our metadata sets. And finally, we have constraints and maps. Actually, this also drives the normalization steps of validation and mapping, of course. And this is very close, of course, to SDMX, because constraints and maps would help you validate if the content is what you expected, and transformation for going, as I said, from the different stages of how we ingest the data, from the raw data, which might be maybe unstructured and not even close to what we would expect, to a data set that is very close to our data dictionary definitions. So this is a high-level architecture of the of MEDL. So it's not easy now to go through it, and I don't think the purpose is to bore you with all the details here, but it gives you an idea, for example, on the left side, on the different sources that we get. And I think the most important aspect here is the last blue box you see on the left, which is called BIS processing. So whatever we do with the data, we feed it back to MEDL. So it's always the data that's produced transforms, it goes back to MEDL. So this is where all the data reside. Okay, so we don't use any alternatives in that context. The other interesting thing, of course, you see the three phases, as we already discussed: ingest and archive, normalize, integrate. And I think what is really important, especially in the context of SDMX, is that the FMR drives the whole process. So you see on the bottom, the FMR is actually driving the whole process. And currently we are using the FMR 11, so our open source software that we have been discussing yesterday to support this, to support MEDL. So where we are now, so currently we have support for SDMX 3.0. So we have transformed all our metadata because you know that from 2.1 to 3.0, there are certain limitations, especially for structure maps, even for reference metadata. So there are things that need some handling. So we have done this already. We have added a few things like the dynamic handling of code lists, which is actually powered by the reference metadata set. And in that context, we also support ingesting data with codings that we don't even know and adding them at the second step. So this is supported by the whole process. Of course, yes, the migration to the FMR is, let's say, in progress, but really, as I said, I think we are on the 99%. So it's still there just in case we missed something. Then the heartbeat that you see there is our monitoring tool. And this is actually where the users, after they are informed about the outcome of their data flow exercise, let's say, they can observe the data, they can browse, they can see the errors that occurred at a very detailed level. So this is also under construction, while it's also advanced quite significantly, and we are getting some useful feedback also from our users. So we did not introduce it after we built it. It was built actually from our business users. We still need to finalize the support for the non-destructive data corrections. So, and in order to support the submissions replay, because I think I did not already say it, but anything that the user does, so deletions, additions, or whatever he does on the data, nothing is lost from the database. It's only marked as deleted or edited and so on. So this way you can support the replaying all the data, so supporting all the history. And of course, Heartbeat plays a crucial role in the editing of this data set. Then, meanwhile, we have our data dictionary. MED is our department in the BIS, so we call it MED Data Dictionary since we're responsible for setting up a harmonized set of concepts code lists across the BIS datasets. And MEDL, of course, plays a significant role there because we use the data dictionary and we get feedback from the whole process, and we try to improve the data dictionary as a result. And finally, we still have some SDMX NiFi processors to implement, but I think we're pretty much there. We are hoping we have done some exercises with specific data sets. We are stretching a bit now with some new, really granular data sets that will introduce some new challenges, but I think we will be very soon in production with our first attempts. And yep, that was all. Thank you for your attention.
So let's start us. And we turn to the audience for questions.
Thank you for the presentation, Stratos. Just you mentioned FMR, and actually also it was mentioned in presentation by EMA as well. What do you mean when you say FMR is driving the process? Because it looks like it's just a point of query for the XDMX REST in your schema, I think. But what do you mean by it? I mean, what means are you doing? How is FMR actually driving that process?
Yes, so actually all the configuration for the flows, so for the flows of data ingestion and all the transformation validation is supported by metadata stored in the FMR. As I said, of course, you will find the typical structures for the data per se, but also configuration for the how the NiFi processors will have to behave, let's say, in this whole process. So we don't have any configuration at the level of the NiFi, but everything is generated actually. Also, I think you've seen, I've discussed about generating the HDFS structure, also the Avro schemas. Everything starts from the FMR. Of course, maybe not everything is, let's say, automated, I think, at some point, but the main thing is that we keep all the configuration within the SDMX structures. Rafael would like to.
Yeah, and Jonathan, if I can add, that actually goes even further than what Stratos just said. For example, if you want to onboard a new data set, then you first enter it in the FMR, and then the FMR populates the data catalog in the bank, and the data catalog then serves as the golden source. Or the FMR is the golden source, but the data catalog then, if a user wants to do some manipulation in the data catalog, for example, add some technical documentation or specifies the data owner, etc., it writes back into the FMR. So the FMR is actually also driving the data catalog. If, for example, I mean, Stratos was talking about medal managed. For medal unmanaged, if a researcher wants to onboard a small data set only for a specific research project, then you basically specify in FMR, you provision the space in medal unmanaged in FMR through configuration. So how much space do I need? Who should have access, etc. And then you basically click execute, and then it generates in the background all the environment and everything what you need in order to save your data and process your data. So that's basically what we mean with FMR driving the entire process. Yeah.
So it's like a metadata driven. This is what FMR is doing. It's a metadata driven process.
Yeah, exactly. And by the way, for the data catalog, I think it's a good example of having an alternative UI in front of your FMR, because the FMR is for us considered most as a service rather than a UI. So our data catalog is actually via the web services updating things that you might have otherwise done on the FMR, but we try to create also UI that are more familiar to the business in that context. I think that was also interesting to note.
Yeah. Follow up. That means that all these other tools that you use consume the metadata through the SDMX API?
Essentially, yes. I think that in some cases we do some caching in order to avoid very often queries, for example, of some codings and stuff like that. But yes, the source is the FMR. Everything comes from the queries.
I don't see further questions. Does anyone have anything else? Sounds like a no. Maybe I will ask because I see there's some similarities between what you're doing and what we do at the ECB. Maybe you can talk a bit about the challenges you faced also in terms of processing and so on, implementation.
Yeah. So I would say more challenges on the business side. So for example, we have a lot of questions of, okay, you're building this new system, but how that will make my life easier? Would it be faster? Because we're talking about big data and all this infrastructure. And I would say it's not easy to respond to that if this is going to be faster, because for now, anyway, we plug drivers on top of it for users to access the data. But yeah, it's really hard to respond to that, even to our business users. Now, other challenges that we are already keeping in mind is, for example, for the heartbeat UI. So this editing tool that I was talking about. So currently we are having an exercise with a data set, granular data set actually, which I think has some 150 columns. So this is really, really granular. And this puts some pressure on us on how to use this UI, because, you know, I mean, the browser has a specific width. You cannot go indefinite. So yeah, there are a few challenges from a usability point of view, I think. Now, from a performance point of view, I think it's quite early at this point. I mean, as I told you, we're just getting into production, our first data ingestion exercise. So it's quite early to talk about it. I think Rafael would like to add.
Yeah, maybe on this one point, processing speed. I mean, clearly our vision was to invest into the future. The data sets which you have at the moment, they are not extremely big. I mean, everything around official statistics is quite small. The bigger data sets which we have at the moment are our depth securities, so security level databases. Okay, but again, you could store them in a column store type of storage, and then it would be fine. Yeah? But similar to the ECB, we can see the data sets actually exponentially growing, and it's just a matter of time that we will have performance issues. I don't think if we go live now with our system, I don't think our users will, let's say, see a big difference. They are also not complaining at the moment that it's very small. Now, in terms of challenges, there's actually one big challenge, and this is the adoption of our cloud strategy. Because in the past, everything was on-premise, but we basically move more and more compilation into the cloud. And I think we need to carefully think which components of Metal we are making cloud ready. So talking about Azure native functions, for example, yes, we have certain components running on OpenShift Kubernetes, but that's not always ideal. So Stratos was mentioning that we actually want to make more use of NiFi processors. Yeah, because you actually remove a certain, let's say, bottleneck. The network bottleneck, for example, if you run things on OpenShift, you need to first get the data from the big data stack into OpenShift back. So there are, it's not always trivial with all the network policies, etc. We always have problems. So, so therefore, the question is, which roadmap do we define in order to make Metal also cloud ready in the next 2, 3, 4 years? Which components do we want to change? What do we want to adopt? So that's actually keeping us pretty busy at the moment. Yeah? So that's definitely a challenge. Thanks.
What is the timeline for this move to the cloud?
Let's say at the moment the target is in 2 years. So I don't think we will be pushed, but I think eventually, let's say the on-premise infrastructure gets very expensive, and our central IT department will say, we are not going to pay your servers anymore, so you need to come up with a solution. Yeah. So my target is in 2 to 3 years.
Also always told it's cheaper in the cloud, but then I hear people say it's never cheaper in the cloud in the end. So I don't know. But one comment about is getting users to like the new technology. It's a lot easier when you have deadlines. I don't see any more raised hands. We're a little bit early, but I suppose we can wrap it up a little bit early and have a break now, and then we can continue after the break. 15 minutes. So we come back at half. Thanks a lot, everyone. Thank you.
We ask all the panelists to come on front of the stage, please. We are about to start. De una, seguramente, aunque nosotros no seamos. Pues o sea, acá como había, no se escuchaba bien ni nada, 2 minutos. Entonces les llamé al escenario, pero falta uno. Entonces, como no están completos ahí, todavía no. Ajá. Entonces ahí sí. This is the final call. We ask all the participants and panelists to come to the front. Thank you. We ask all the participants to take their place, please. We are about to start. Thank you.
Okay, thank you. So welcome back. So now we will continue with a final presentation in the context of our big data session. And for this, I'm glad to introduce you to Jan-Hendrik Hühne, Head of Professional Services. So Jan studied informatics at Bauhaus University Weimar. From 2011 on, Jan has been working as a consultant for the Bearing Point Group in the core insurance, core banking, IT advisory, and the supervisory technologies domain. And since 2020, he's working as the head of Subtech for professional services at Technology Group. And in his career, Jan-Hendrik was responsible for different projects in the banking and supervisory area, like in the Deutsche Bundesbank, Central Bank of Cyprus, and Bank of Lithuania. So Jan, the floor is yours.
Thank you very much, Stratos, for the introduction. Yeah, so finally presentation for today. And yeah, don't be confused. There are many titles around that presentation. This one differs from the one in the agenda, but I think the content is more or less the same. So I would like to talk to you about granular data, how I called it with SDMX. And today I heard also the wording microdata with SDMX. So I think it's in the end, it's the same. So the content of the presentation is I will quickly introduce Regnology, so my company or the company I'm working for. And then let's go to my use case, the credit register we have implemented for the Central Bank of Lithuania a couple of years ago. We will have a look on the use case itself, on the data storage, the architecture of the solution, and last but not least, of the different steps of the validation rules. And yeah, as Stratos announced, I'm the head of professional services. I'm no developer. I'm no functional guy. I asked my colleagues to give me some thoughts about what could change with SDMX 3 for microdata. So yeah, let's see. And some stuff I think we already heard today. So who is Regnology? We are a company which is providing software solutions for regulators and also for the regulated. So about 7,000 firms are reporting to their financial authorities with our RegTech and tax solutions. We have round about 50 regulators and tax authorities who are using our software solutions. Since we have acquired the Visa firm. Last year, we are now a global RegTech and SubTech powerhouse. We have in 12 countries where we have a local presence, and we are around 800 people, and 100 are taking care of SubTech and AOI, and the others are for the RegTech and the tax business. And of course, we exist over 25 years in the market. So I think that's it. And of course, with our newest solution, we are completely cloud native, looking to the right side. But this presentation will be about a solution from us in the former versions. So the use case is that the Central Bank of Lithuania decided a couple of years ago to renew their existing credit register. And the trigger for that project was the announcement of the ANA-credit regulation of the European Central Bank and the possibility to extend this regulation by national needs. So ANA-credit is based obviously on SDMX 2.1. And the ANA-credit regulation has been extended by additional data sets and additional attributes in existing data sets to fulfill the needs of the Bank of Lithuania for their national credit register. So the idea was to combine the national needs and the ANA-credit regulation to reduce the reporting burden of the financial industry, so that they only have to report, let me say, one data collection to the central bank. To reduce the data volume, one of our, let me say, biggest problems was the implementation of a delta mechanism, so that the financial entities are only delivering changes to previous submitted data, and within the data warehouse, everything will be put together to have a clean history with all attributes available. The standard submission frequency of ANA-credit is monthly, but to fulfill the needs of the credit register, we had to change that to a daily submission. So in Lithuania, the whole industry is submitting the ANA-credit data on a daily basis to the central bank. And yeah, out of this, then by each end of the month, the specific KPIs for ANA-credit will be calculated centrally by the central bank. To complete that credit register, of course, there is a query engine required for the local industry, which has been implemented based on SDMX 2.1 to query the credit register. And also we have implemented a feedback loop back to the submitter, also in SDMX 2.1, to provide the feedback of validation rules back to the local industry. Oh no, I need that one. Yeah, so here to put what I said earlier on a slide. So 120 reporting agents are reporting to the central bank, about 200 queries per day about loans of non-financial corporations, around about 100 online customer requests per day, 500,000 of new records per day, which are coming in from the local industry, and 7,000 queries per day about customer loans out of the credit register. And on average, the response time to a query to the credit register is around 7 seconds. So also here we had to put a lot of effort in optimizing that, so that there are no delays between submission and receiving of a proper answer. Yeah, so there are a couple of different storages. So we have two main storages for all that stuff. So one is a file storage where everything what is SDMX related will be stored. It's just a network device where all the files are. It's in the end the SDMX submissions, the SDMX query request and responses, the reply messages, and last but not least, the finalized ANA-credit files. And we have a database storage on Oracle where all the staging data is getting in, so the parsed SDMX submissions and the data from external systems. We have a live data layer, which is bitemporal historized. So you have a full track of all changes, and it doesn't matter if it's from a business or from a technical perspective. And the whole history is also available. We have a final data layer also completely historized, calculated one time per month. But unfortunately, it's 1 day behind. We need that to ensure that the results of the query engine are constant over 1 day, so that you don't get different query results when you submit multiple queries per day. Then we have a monthly data layer where all the data is stored from a month in a monthly snapshot. This is used for unaccredited and includes also the unaccredited transformations. And last but not least, we have our unaccredited data layer. This is part of our technology software, where the official ECB validations will be executed, and from where in the end the data submission to the ECB is happening. And we have an area on the database where all the validation results are stored in. Yeah, so looking forward on the overall architecture, it looks more complicated as it is, and it goes along the different layers I have introduced on the previous slides. So at the beginning, on the left-hand side, the SDMX data from the local industry is getting in, and on that data we are doing the SDMX schema validation. We are checking if all header attributes are fine. We are checking if this is a duplicated submission, and we are of course checking if the submission. If the submitter has a right to submit for that legal entity. Once we have passed the file level checks, the data will be crunched and stored in a staging layer. And in the staging layer, we are validating if, let me say, the data is complete. So if the business keys are in, if all required attributes are in, and so on. After the on-submission validations are passed successfully, we are compressing the data. Compressing is, yeah, let's keep that wording, and writing it in the live data. The live data is a fully historized data storage where all the data of all data sets is in a relational way, as I said, on an Oracle database. But it is still on a legal entity level. So for example, if 2 legal entities submits the same counterparty, then on that layer, we have 2 records for the same counterparty. So also here we are checking if everything is completed, if everything is in. And if we pass that checks, we will move forward to the final record. Final record means in that case that we are now merging the data of different legal entities together. That means in the end, we are trying to identify the same person from different legal entities and combining them. So in the end, we want to get an history by each loan holder, and we want to see all the loans he has. And we don't care about if its loan is at bank A or if it's at bank B. So in the final record layer, everything is harmonized, and yeah. So here we are doing also the daily validations, and we are checking if now really everything is complete. We are checking if all records which are required for the final record data are there. And we are also checking by each end of the month the monthly validation rules. So if also all the attributes are available now, which are required for the month end. So this we are doing every day. And also we are providing if something pops up during the different validation steps, we are returning the messages back to the submitter so that he has a possibility to correct and to fix the issues and resubmit the data immediately or on the next day. Once a month is over, we are calculating out of the final record data the monthly data. So we are calculating KPIs and KRIs the Bank of Lithuania requires to steer their business, and also which are required by the ECB to complete the unaccredited data. If this is done, the plausibility rules are run and everything seems to be fine. We are exporting that data from the monthly data layer into SDMX again and transferring that over the file system to our Regnology software, which is called Abacus 360 Regulator. And in that software solution, the SDMX files will be now imported. The ECB unaccredited validations will run. If everything is fine, the SDMX file will be forwarded to the ECB, and we will provide a reply message to the submitter that the file has been reported and everything seems to be okay. So that's in a nutshell the whole architecture of the solution. And I think it's quite similar what we have seen before. I think you are storing the stuff also in a database and running validations in the end on top of it. So unfortunately, this is not cloud ready. So as I said, that's all on Oracle, all serialized. But in the end, it's working, and Bank of Lithuania is reporting with that solution since I think 2019 to the ECB, and also the credits register is used by the local industry in a very intensive way without any complaints. So looking forward to the validations. So I have summarized here what I said earlier. So on the file level checks, and that's what we are doing in the SDMX scope in form of the schema validation. So we are checking the code lists and the mandatory attributes. The mandatory attributes in that case is very small, while we need to be ready for a Delta delivery. It's really the minimum set of attributes which is required for the further processing. Then we are checking, as I described, the header attributes. So if everything is completed, this will be done inside the application and the ETLs. We are checking if the submission is a duplicate from a former submission. And we are checking, as I said, if the submitter has the rights to submit that. Also, this will be done within the application and the underlying ETLs. When we are looking on the database side, everything, what happens afterwards, so the on-submission validations, the counterparty validations, the completely validations, the daily validation and the final record validations, the monthly validation, everything will be done in SQL. And yeah, so that's what we have here. No, that's one too fast. So what are the advantages or disadvantages of SDMX 3.0? So when I talked to my colleagues, they said to me that the reference metadata exchange in 2.1 and earlier was too complicated, and with SDMX 3 they told me that the reference metadata sets which are attached to structures or lower level components can be reused, which would be very helpful. I think how to model microdata, we already heard in the first presentation, and that observation value could be empty or filled with such a figure is a solution. So new features to support microdata, like the microdata exchange, multiple measures, multiple values for attributes, and simplified DSD dimensions. And last but not least, extending a code list means creating a new code list. And with SDMX3, there could be global code list used without having bigger worries about their maintenance. Yeah, so that's from my side in a nutshell what we did at Bank of Lithuania. So looking on my watch, I'm also, I think, 10 minutes too fast. So probably for you the afternoon will end a bit earlier. So any questions?
So, yeah.
Let's see which questions we allow.
I have a few questions myself. So don't be so sure we'll get back earlier. So okay, let's start. First of all, thank you for the nice presentation. And yeah, who's getting the mic first? Jonathan?
Probably I need the slides to answer the questions.
Yeah, and maybe especially the one with the architecture will
I'm not sure this was on your slides actually, but yeah. So what was the driver? I don't know if I quite saw that there, but what was the driver for using XDMX, for example, as opposed to XBRL? And also maybe you showed the sort of architecture there. Is the internal format XDMX or is it just the input output? So are you actually, the whole flow, is it XDMX? Are you?
Okay, so let's start with the first question. Why? Let me try to find it. That one. Yeah. So why SDMX and why UnAccredited is based on SDMX? Unfortunately, I can't answer. Probably you have to ask at the ECB.
Maybe it was an ECB driver. Yeah.
Zlatina, would you like to get the microphone, please? Yes.
There were long discussions what kind of format should be used, and we involved also national central banks in these discussions, and it was decided that SDMX 2.1 will be used. So soon we had to implement it.
Okay, so we can blame you. Yeah, thank you.
So and to the second question, no, it's only the, let me say, for us as also for the central bank, it's just an exchange format. So and when we go back to the architecture slide, unfortunately this here is not working anymore. Now it's working, perfect. So when we look here, so when we started the project, we were not absolutely clear how the architecture will look like. And while our software is based on SDMX, while UnAccredited is, we decided that between the credit register and the Abacus regulator software, we want to keep the SDMX format so that probably the credit register can be changed by another solution and all the other stuff is still working. Because of that, we are saying we use SDMX on the left-hand side to import the data. Then we are doing everything on a database level. Then we are exporting it and importing it again just to keep clear interfaces alive. Yep. Do you have a number on your micro? Down here? 8 is not working.
Please.
Okay, it's back. Just so, okay, so it's an input and output. I'm just wondering also from your team, because you're obviously outside the normal sort of XDMX community, I would say, you know, for this. So
absolutely.
Yeah, exactly. So it'd be interesting to understand a bit more, expanding on maybe some of the issues you faced and the learning curve that you saw and the wealth of technical documentation available and things like this. How did that maybe aid your team in supporting this project and delivering this project, or not?
Good question. So I would say to say everything what you see here is, I would say, more or less implemented in Java, and Java makes it quite easy to parse XML files and to create data structures out of that XML files. So of course we had to take care a bit of reading the SDMX and understanding what we are getting, because for us it was also new. But in the end, with the documentation which was available from a business side at the ECB, and having some Java skills, it was pretty easy to parse it and to further process the data in the system. But maybe as I saw, not sure, I think it was on your slide, maybe there were also other possibilities to extract the data with that tooling, and to validate it probably outside the application and then use APIs. But we were not aware of that possibility. So for us, it was pretty clear, and our Java developer said, let's do it in Java. So, and then the decision was made.
Okay, thank you. Next, Daniel, please.
Yeah, thank you. It was actually really quite interesting to see somebody from the SUBTEC community here, because usually when I hear SUBTEC, I hear DPM XBRL. So a bit of a follow-up question to that, because we are working quite a lot in trying to integrate DPM XBRL, STMX, and also looking in how we can solve this challenge. And from the vendor point of view, outside now of the unaccredited specific project, but do you have any view on how this can be integrated, or what the role could be of these two standards in the SUBTEC world, let's say, about SUBTEC reporting, or how do you see the market there developing?
That's a good question. So looking on the standards, I would say, look from a SUBTEC perspective, setting up a taxonomy in XBRL is quite heavy. So you really need an XBRL expert to implement a complex data collection in XBRL. As I said, we have implemented the query engine and also these reply messages also in SDMX 2.1, and that was, with a bit of research, quite easy for us to do it in SDMX. So in the end, I think it's a question about the regulator. So ECB is saying for unaccredited, we are using SDMX. EBA is saying for EBA ITS, we are using XBRL. And when we are looking on, for example, national data collections, which are not supervised by another authority, probably it goes to Excel. So everyone is asking for Excel. But I think it goes more in the direction of JSON and so on, also because it's much easier to access it over APIs and so on, instead of sending files around the world. That's my impression I have at the moment.
Just a quick follow-up on what you said, because you said you're actually reporting probably similar data in SDMX, XBRL, Excel. So is there any part of this architecture common in that context? I mean, it could be not necessarily a component, but at least some logic behind it, I guess, should be shared, or?
I would say what we did here is really very special for Bank of Lithuania and unaccredited. So I don't want to say that we are able to replicate that for another authority when they want to have a credit register as well. So that will not work. But as I said, we have we launched a completely new platform for our SUBTEC business, where we are internally complete format agnostic. So it's completely based, it's completely cloud native. And what we are doing is, once a submission is coming in and we don't care about the format, we are taking it, we are shredding it into Parquet files, and then we are processing it further through our APIs, also with Camunda. And for that, of course, we need the importer for XBRL or for SDMX and so on. But after that, when the data is once read, we are completely agnostic, and then we are operating on Parquets.
So this is based on the specific model for the unaccredited, for example.
Yeah, that absolutely.
Okay, thank you.
Okay. Thanks, Jan. It's actually a nice addition here to the presentation we have, the usual presentation. So thanks a lot. A few questions from my side. So you implemented this for the Bank of Lithuania, but I mean, you have a pretty wide market share, yeah, on the regulatory side, with Abacus. Is this only a Bank of Lithuania implementation, or are you actually reusing this implementation also at other central banks and maybe even outside of the euro area? Are there any similar demands or projects where you use this implementation with SDMX maybe even? So that's my first question. I don't know.
At the moment, not. So the credit register topic is, I would say, more or less for all central banks or for all authorities who are dealing with credit data. It's a topic, but I would say we need to look on the drivers behind it. So, as I said, Bank of Lithuania wants to provide on a daily basis a credit history to all other banks when someone is an applicant wants to have a loan. So other central banks or other authorities just wants to have it on a monthly base for internal usage. So there are very, very different demands in the market, and that implementation we only did that at Bank of Lithuania.
Right. And another question. So what were the biggest challenges actually when you implemented this at the Bank of Lithuania? Was it around the modeling, or was it more around, let's say, setting up the operational, let's say, structure at the Bank of Lithuania? Who is actually operating this at the end? Is it you? Is it completely?
It's completely on premise.
Okay. Mm-hmm.
Yeah. So the biggest challenge. Good question. So what I said earlier, so the trigger for that was the ANA credit regulation. And the second thought was the credit register. And these both components needs to be combined also with the challenge of a daily delta reporting. So we can't collect the full set of attributes on a monthly base like it is in the regulation. So and then we have to enhance the 9 standard data sets of ANA credit by the custom ones, including the custom specific attributes. And also we removed some KPIs which normally is part of the ANA credit regulation, because this Bank of Lithuania is calculating centrally on the monthly data level. So and to get all that business logic including submissions, resubmissions to ECB, feedback loops, and to get everything sorted in kind of a job scheduling was more or less the biggest issue. Of course, performance is also an issue. Huge data on an Oracle database that's working, but also here, and we were not so flexible in the data model because that was more or less defined by the ANA credit regulation. So and we also took that data model through the whole chain, and so the database optimizations were also kind of an topic, and of course the logic to match the same person from different banks to one person in the end. So that when you are having a loan at Bank A and also a loan on Bank B, that we are getting these together to you as one person. That's kind of, you need a bit of logic in the background to ensure that matching.
Okay. It's actually also interesting to talk about this matching logic, because it's a typical problem we also face for many of our exercises. So if, let's say, some parts of the SDMX data format, the submission format changes, is the Bank of Lithuania independent enough to make those changes then, the configuration or model changes within the system, or are they actually relying on you? Have they been trained enough to really understand how this, how to operate this,
Yeah, I would say yes. So we had a lot of training sessions also with the business department, with the IT department. So I would say they are able to do that. But their big advantage is they launched a new project where we are also part of. So we are back in the bank and they could ask us.
Okay, yeah, that's done easy. Okay,
Things done.
Thanks a
Thanks,
lot.
Rafael. Any more questions? Yes, Glenn, please.
Yes, just picking up on Raphael's point about sort of changes perhaps to the message. I see on the collection side you're using what we call SDMX schema validation, which I think is XML schema validation. So if there's a change, how are those XML schemas, those XSD schemas being regenerated, because they're quite complex things? Is there a tool to actually generate those?
Don't ask. Manually.
Okay.
Just a quick follow-up on that, because I also had the same question. So essentially you don't, I mean, you have a DSD on the input side, which is designed by you.
I would assume by the ECB. We are taking that from the ECB.
Oh, so you use the same DSD actually. Okay. Please, Glenn, sorry to intervene.
No, that was all. I was just interested in how the XSDs were being generated, but if it's a manual process, then understand some very skilled people there.
But as I said, our changes were more or less adding the custom attributes, and that's in the whole context of the schema. It's just minor changes which you could do very good.
Thank you.
Just in terms of numbers, because you talked about validations and performance challenges, but there were no numbers, and I was wondering, maybe you could talk a little bit about this. How long did it used to take? What did you do? What's the current state of affairs?
Well, as I said, it's quite a long time already in production. So I think validation rules, it's around about 200, which are implemented. So overall stages which are implemented in SQL. Of course, they are then will be only applied on that stage where they are valid for, and then we are also running the ones which are runnable in parallel. We are running in parallel. So and when we went live with that project after doing the initial load, I think from the beginning till the final record until the live data was generated, it took around one or 1.5 minutes. But as I said, it's only deltas, so it's a very low number of data.
This is on the 500,000 a day, or
yeah, but overall entities. So.
Thank you. Any more questions? Yeah. Okay, so thank you very much. Now, currently we are at the part where we would animate a bit more discussion along all the participants here, but what we were thinking of doing is, of course, we will not do any Mentimeter, but we would like to get a bit an idea of the audience's involvement in microdata. So I have a few questions in front of me for the audience, and just by raising hands to get an idea of how much of the audience is involved in this process. So first, how many of you are involved in microdata processing as an indication? We're relatively, I wouldn't say more than 25%, counting well. And then how many of you are processing microdata with SDMX? I guess 2.1 and okay. That's relatively, I mean, we would expect that. And then anyone planning to use SDMX 3.0, even if you're not doing it already? Okay. The usual suspects, I suppose, yeah. Okay, nice, thank you. Now the next is a bit more technical in the sense of the capacity to process granular data. So do you think you have enough capacity to process it? And I think it's mostly on the at the infrastructure level. Of course, this depends on the order of magnitude of microdata that you're processing. But do you believe that you are ready to do that, or do you think that it will require maybe more effort or investment? So anyone would like to respond to that? Edgardo, you're thinking. I think you can take the microphone and express your thoughts. I see also. Okay. I think it's Angelo there.
Yes, Angelo.
Yeah, Angelo. Okay, good. Then Edgardo can follow.
We have a good experience of with dealing microdata because we are the service provider for an credit for all the system of European Central Bank. So Lithuania is sending data to us. And actually, we see that the DB technology is reached with such a volume. And so we are internally, and perhaps also externally, for having service provider to go obviously on big data and cloud, both on prem or public cloud, depending on the information that we are dealing with. Obviously, we are not going to public cloud for certain central register, that's for sure. Probably we will go for unaccredited on cloud because there are no personal data at the moment. So the GDPR is safe on that, and the confidential statistical information at the moment, the risk has been set medium, let's say. And I'm speaking under control of Latina, obviously. And so not only for statistics, but also for other domains. And we currently we have our cloud on-prem, and some services are going to be probably moved on the cloud.
Okay, that's very nice. Thank you, Angelo. So Angelo is from the Bank of Italy, just in case, yes, you don't know him. So, yep, thank you very much. Anyone? Yes, Edgardo, of course.
Regarding the question of process, in our case, thinking of labor force service, for example, the processing is not of a huge amount of records because you normally process cohorts of data. So you process the labor force survey of your country for 1 month, 1 quarter, or 1 year. So you're talking maybe some hundreds of thousands of records, but not more than that. And I think that there's no difference of processing the data now with the new model using multiple measures. There should not be much difference processing the data in SDMX CSV rather than processing in other formats, basically. So I don't see a performance issue there. Now, taking statistical registers, that could be a different story because there you can start adding data like you do in the financial industry, and then the volume can reach other numbers. But I think that the solutions in different formats is there, and I think that not for SDMX 3.1, but maybe for 3.2, we will have to start think of these kind of things. But I know Jens has already been thinking of that in the Task Force 3. So good.
Thank you. I see Pedro just behind you.
Yeah, so yeah, the same as Edgardo. For us, the behind the scenes model is more or less the same. So we're expecting the same speed. Although I don't know for sure how much is the quantity of data that we will, so referential metadata that we need to process. But the one thing that I saw that could be a potential issue is that these attributes, metadata attributes, they can be more extended, each one of them. So you might not have as many records, but they're wider, each of them, and that could become an issue.
Yep, and I guess increasing complexity could introduce some problems because it's not anymore a flat record. It might be, yeah, something hierarchical within your flat record. Okay, yes, thank you. Anyone else would like to contribute? Yeah, Rafael, please.
Thank you. Actually, a follow-up question to Angelo and maybe Pietro. So obviously cloud adoption, and I think ECB is also quite involved in that. So maybe Almir can also add some remarks there. So I mean, cloud adoption, cloud strategy is quite prominent, yeah, when it comes to microdata. Yeah? A lot of institutions have this strategy that eventually they want to move their processing, storage, etc., to the cloud. I actually have 3 questions. The first, are there concerns in your institutions regarding the big players? Yeah, and not so much from a confidentiality perspective, more from a dependency perspective, for example, and in maybe other dimensions. The second question is, I mean, when you use the big data stack in the cloud, then there are different options. I mean, from an SDMX perspective, you actually promote quite a lot open source technologies. But if you go to open source, then yeah, you have issues, compatibility issues. If, let's say, certain components are upgraded, then others are not, you know. Which strategy do you have actually, Cloudera alternative strategies, for example, to set up microdata systems in the cloud? I know, for example, at the OECD, you are collaborating with a consortium in France, yeah, who is also providing open source technologies in the cloud on a French cloud. Yeah, so maybe you can just elaborate a little bit on this. And yeah, oh, Angelo, please.
Well, at the moment, we are just, let's say, practicing the big data on-prem in order to be ready for going, because especially in Europe, probably there will be perhaps the European cloud. That's the Martin Luther King, I have a dream. So also the confidential data can be there. And so that's another thing, because a lot of risks are there, obviously, for foreign providers that are outside of Europe. That's the first one for confidentiality. The second thing is, let's say, we are just practicing. We are in a gym in-house in how to deal with big data in-house before going there, because in that sense, probably the transition will be much easier. So that's why we're moving some services on-prem at the moment, because going on cloud probably will be also there are other problems that are not just technical, pricing and so on and so forth. So at the moment, that's the way we are doing. And we are starting also with statistical application. The big data is used now for EMIR data, which are very big volumes on this. And so, and probably our InfoStat platform will migrate in cloud, in big data in the next years. And we will see if on-prem or directly in cloud. Probably there will be a 2-step transition, probably.
Okay, but what I hear is you're actually waiting for the European cloud, yeah? Yeah. Okay, interesting. Thank you.
Interesting. Pedro, would you like to yeah?
Yeah, just to reply. I'm not aware of the open source tools that the OECD is working with the French company. So in the context of the DOSTAT suite, we are not. Maybe other departments.
Yuri mentioned something to me. I don't know, Jonathan, maybe you're aware of this. I think it's pretty much at the start, as I understand, yeah. But
I don't know. I have to check because I am not aware of this either. Yeah, probably a small project within one department we may be working with or something. I'm not sure, but
yeah, as I understood from Yuri, it's more knowledge sharing at the moment. Yeah, so actually the French government, as I understand, they are promoting this forum where basically organizations in France are sharing experience, and they're also investing in infrastructure, which eventually could become a French cloud. Yeah, but
I have to investigate. Sorry.
Okay, yeah. And I'm on the ECB side.
I think Zlatina would like to have the mic. Yeah,
I
thank you.
just want to say, I mean, to summarize what is the strategy on ECB side. So we have a cloud strategy and it's quite ambitious actually. So the plan is to have 80% of the applications on the cloud by end of next year. Quite ambitious. And there the key word is confidential statistical data, and based on the definitions that we have internally, this is data which with the help of which we can identify entities. So this is confidential statistical data. Everything else will definitely go to the cloud, and all of the applications are starting now to be migrated there. And as cloud providers, we are using, yes, the big players. We have some constraints that the cloud physical location should be in the European Union. I know I'm not from the IT department, just the information that I have. So yes, indeed, we are really moving towards this direction. This will be the future.
But all cloud providers could, at least in Europe, provide a data center. So Europe is not an issue.
Yeah, that's right. Yeah. Even creating some data centers in Switzerland at the moment. Yeah. So, and what about Inegi? Is there actually some strategy to move some parts of their infrastructure to the cloud? I don't know, Juan or some other colleague. What are the plans there?
Well, exactly, we don't have a plan to move our infrastructure to a public cloud. We already have all the reference infrastructure for SDMX in our own premises, and we have a private cloud. So by now we don't have that kind of need. And if we in the future we are always open to move to the cloud, but it depends of other not only technical situations but also economical situations. If you make a cost benefit evaluation and you see that going to the cloud it is going to work for Inegi to get more value at less cost, we are going to the cloud. We don't have any problem with that. But before doing that, we are very serious about that. We are very serious because our law commit us to get the better price, the best price for the best price and value for Inegi. So that's the reason. It's not a reason of this is a fashion or something like that. No, it's about what is bringing more benefits for the institution.
Okay, and if I understand one, you already did some analysis, and at the moment the costs are lower for the on-premise setup. Yeah. Okay, interesting. Yeah, thank you.
Yeah, but I mean, considering also the maintenance burden, it's because this is also a quite big cost, I guess. I see more hands.
So yeah, just to add more information within the context of the DOSTAT suite. So the DOSTAT suite, we have it as a platform available for many users, but one of those is the OECD. So in general, the DOSTAT suite, we, for demoing purposes and so on, we have everything in the cloud, the whole thing. For the OECD, we have a hybrid solution where the backend and the data is stored on premises, and the front-end GUI applications are in the cloud. And this is because of the OECD requirements of the confidentiality of the data. And just to say that, yeah, we have it's tested in the cloud and hybrid approach, both.
Just maybe a comment or question, because I think someone mentioned it about the cost. I mean, with .stat, at least we have a sort of understanding or not knowing of how much it's probably going to cost us. But when you have things like, processing of microdata or big data or things like this, I mean, sometimes you don't know what the sort of cost might be, because you have to have a scale up, depending on the volumes you're dealing with. And maybe someone runs a query that is a bit silly or something, and you just don't know what's going to happen. So, is it really, cheaper to go to the cloud in these scenarios? I don't know. I mean, you were saying, Rafael, I think about your infrastructure pressure, maybe pushing to the cloud, but is this going to be more expensive in the long term?
I think it's a good question. And I agree with you. I think there are quite some interesting reports from McKinsey and other consultants who basically say it depends whether you go as infrastructure as a service into the cloud, and then the costs are pretty similar, if not even more expensive in the cloud. But if you use more platform as a service or software as a service types of offers, then actually you can actually decrease the cost. But it depends on your use case, whether actually, you can use these type of services. Yeah.
Thank you. Yes, please.
Yeah, I can just add. So also space will be going to the cloud. I think they've done now some pre-analysis. It's finished. The decision has been made. And somehow I find myself in the minority who doesn't like the idea of putting all of our confidential data in the cloud, but no one asked. So the plan is, I think we go next year. And the IT department is very fond of this idea. They don't have to maintain anymore on-prem. So there's no more hardware. There are also some good arguments for this. For example, for this particular big data set that we have, which gives us all of these performance issues, it's semi-annual data. So if we need more capacity, we basically just pay for it twice a year. We produce the data and then we scale down. How it works out in practice, this we have to see. It starts, I believe, the end of next year, which is just about at the end of the space project. So then immediately we start moving to the cloud. Then we will see how it works out. But like Zlatina said, there's a very strong push to move to the cloud. So it's happening.
Thanks a lot. Yes, Angelo, please.
Yes, we have also experienced that you're not everything on cloud or nothing on cloud, depending. For example, for SaaS, it depends because they offer on cloud and they offer on-prem. But for example, on-prem, you have to do your infrastructure based on the one that they support. And so the choice of going to cloud is not depending not only on costs, on whatever, but also on the choice that your infrastructure on-prem is. Via 4, for example, will be completely on Kubernetes. So, and so on and so forth. So the problem is not just, obviously, there is a political decision, a strategic decision, but then for each domain, probably each product, each software, probably you will have to decide based on other considerations, not only costs and not only the strategic decision. Someone you are forced to do something based on the offers, on what's on the market, what's on the off the shelf, and SaaS is one example, for example.
Thank you, Angelo. I saw Edgardo also trying to follow up.
Just to follow up on that, I think that price is one of the elements for the decision. I mean, perhaps the first one to look at. But yeah, I agree with Angela that there are others. In our case, that we have different use cases because we are users of the technology, but also we provide somehow advice to our countries to use technology. We have different situations. Ourselves, we follow what our IT department says. Today, the ILO still have a big data center. We use basically Oracle database, but some services has been moved to the cloud. The mail, some administrative applications, these are progressively moving to the cloud. And what I have talked with the infrastructure manager is a matter of pricing, cost benefit. I can mention we are SaaS users. We have SaaS 9.4. We are evaluating the possibility of migrating to VIA. And also they made the analysis and they said they prefer to learn about Kubernetes and have the infrastructure on-prem rather than paying what SaaS want to charge for the service in the cloud. So the decision varies. And in terms of the countries, I can say that most of the let's say medium income level countries that we work with, they are not ready to go for the cloud, at least for a small system like the LMISs. So most of them use on-prem. I don't know how many cases we have, maybe 2 out of 15 that are evaluating or are implementing in the cloud. Despite, of course, Dostal Suite is much easier to manage in the cloud. But
I suppose it would make sense not only for one use case in an organization. So it would, if it would serve more use cases, then it would make sense.
Yeah, but yeah, and also in many countries there are problems with where you put the data. So this arrangement that Pedro mentioned about having the database on-prem and the applications services on the cloud, it could be a solution, but it's also expensive and difficult to manage. So it's not an easy choice.
Yeah, I think we started from microdata for SDMX and we have went all the way to the cloud and all the issues. Of course, it's microdata still, and all those issues are part of the microdata context, let's say. So maybe just to bring us back a bit to the context, I would have a question to the audience, but also to us on the SDMX 3.0 features. So we've said about the features pretty much. So arrays, multiple measures, sentinel data, sentinel values, and so on. But this might not be covering 100% of the use cases. So for example, someone might argue that surveys are also microdata, and maybe some parts of it is not already covered by SDMX, or it is. I'm not sure. We haven't run any use cases yet. But is it something that you still think that belongs to 3.1 maybe for supporting further your microdata use cases? And yes, this is to all of us. I can start myself answering to my questions. Yeah, so for example, yeah, reflecting exactly. So I see Daniel. Yeah, thank you, Daniel.
I mean, I can't answer the question. I can only tell you that it will come, right? Because I think the majority of SDMX3 implementations, at least what I saw, they are not beyond the POC phase yet. So we don't have, I think, real production lines in SDMX3. And we designed SDMX3 basically on stumblestones that we found in 2.1. Because we couldn't do certain implementations, or we had to do a workarounds like Maya presented before, and we solved these issues. But once I think we go full-fledged into implementations, we will see what we forgot. So I think everybody in the room knows that SDMX 3.1 has to come. We just don't know yet what will be there. And hopefully it's not major, and hopefully we thought about everything in 3.0. But it's not an answer to your question. It's just that times will stay exciting, right? Because I think we should do real implementations, and we should continue exchanging experiences on them as early as possible in order to find the stumblestones and discuss them openly then in the community.
Hopefully it would be 3.1 and not 4.0, because then
I didn't want
don't want to
that.
break compatibility again. I see Sid would like to.
Yeah, here again, just my thoughts. Like maybe we should also look at the interoperability aspects of SDMX. So like DDI has been specialized on microdata. Like from a World Bank perspective, we use DDI for cataloging microdata, not for exchanging microdata. But DDI has evolved, and I also heard DDI is getting into time series. So maybe we should look at how can SDMX interoperate with DDI for exchange of microdata instead of trying to force fit microdata into SDMX. Similarly, when it comes to geographic data, like we have GML and other standards. So I think at some stage we have to step back and say this is not our core competency, and we need to look at interoperability with other standards. And even when we talk about big data, I think SDMX core strength is structured data, and not all big data is structured. So if we now try to fix an unstructured big data into SDMX, then we are in a lot of trouble. So my thought is like, we need to have a prudent mix of SDMX capabilities and interoperability with other standards.
Thanks a lot, Sid.
Yeah, I think that something that could be difficult to model in an efficient way is the census data when you have two different type of records. So typically in census, you have household data and persons data. So yeah, today storage is cheap. So normally what you have is you have a huge redundancy of the household data and you repeat the same information in all the person's data. This is what softwares like SPSS or Stata does. But in the ancient times when space was expensive, there used to be techniques to allocate two different type of records in the same file and process hierarchically. So this is not possible today in SDMX with a single DSD.
We have arrays.
No, but with a single DSD. No, it's two completely different layouts that you only have one variable that distinguish if it is household or person data, and then you have two different layouts.
So we will wait for someone to implement it, I guess, and see what happens. Okay, thank you. As for, please, Almir.
Yeah, just to add one thing, because it's actually something we discussed during the break, which is also my excuse why I was late. It was an interesting discussion. The modeling I leave to the experts, but more about the exchange formats, because it was actually with Rafael and with Pedro. And maybe it's time to introduce a binary exchange format, because everything we have now, it's JSON, it's XML, it's JSON, it's all text-based, which of course makes huge files. And I don't think this is going to work out for microdata. It's just too much of it. But with a binary format, I think this could go somewhere. So we will need to think about in the future, how can we exchange millions and billions of rows? It's XML is just isn't going to go anywhere. It's not possible. But binary, I think it's time to think about this.
Thank you. Yeah, that's interesting. Anyone else would like to contribute?
Yeah,
please.
Also for processing huge amount of data in the survey and census business, to have transpose formats also would be very useful, because you normally deal with few concepts at a time. So transpose storage is very effective.
You're keeping notes for TWG, I guess, right? Thank you.
Yes,
So yeah,
Pedro,
I
please.
just want to share, just extend on the use cases that we saw. Of course, this might not be attractive from the business perspective, from the end user, but from the implementer as a technical implementation, this makes a lot of sense. There's many use cases, for example, to be able to archive data in a standardized format that you later on you can retrieve, because you still keep backward compatibility to this format. And there's as well a use case that you can consume the data from these files without having to have a database engine that is always running. So you reduce the footprint, carbon footprint, and that's also becoming one of the requirement. And of course, the exchange of these files in a really compact way, because right now, whenever we're testing this, the OECD provides us a temporary place where we can store such large files, but we can only keep it like 1 week, and then we can test the use case again. Things like this. Anyways, just wanted to share some of the use cases that I see why this is important.
Thank you. I hope we don't have a new task force on carbon footprint in SDMX TWG. Okay, thank you. I think that those were valid points. Of course, yes, as we saw, we started from the simple examples of modeling and ended up to the cloud, but I have some more comments from Jonathan. And then
it was just a point to, I think Jens and Xavier from BIS even had an exchange on this, not binary, but they were going to propose a format, I think, after XMX 3.0, because it's obviously there's a lot of work to do with this, but yeah, I think they're going to make a proposal to the XMX technical working group, at least on this.
I think this is in the queue.
Maybe you know already, I don't know, but
all I know is, yes, that's something in the queue, but yeah, no details that I could share. I mean, we have Edgardo here.
Confidential.
Okay, thank you. So I think, yeah, we were a bit early, but I guess it was quite a fruitful discussion. So just a bit to draw some conclusions from this interesting panel. I mean, one interesting point that I've noticed is that SDMX was pretty easy to implement. So this was what, I mean, okay, it was not a full.
I said to read it and to write it.
Still, we have a lot of discussions within the working groups, not only the technical, about the complexity of the standard. So, I mean, I'm not saying you build a super SDMX system, but still understanding the model and implementing at least parsing was relatively, let's say, rational. It was not something crazy. So I think that that's a good point for SDMX. Then we also saw that until now 2.1 was the only way there were only workarounds. And I think that 3.0, actually it was designed to support our use cases. So let's hope that we can get there. I mean, there are a few attempts. I mean, we are also trying to do something at the BIS, but I hope that more, I expect also Eurostat to do some work because they are quite active in that context. And yeah, I think that's really, really useful. And then, I mean, microdata is, I think, goes a bit beyond what we can do as a standard because there are so many issues around it that we have to consider. And I'm not sure they could be all considered as part of what we are discussing on modeling and preparing ourselves for the big data, like footprint of the of the processing or confidentiality and so on. So yeah, there are quite a few things that we should consider. But I'm quite optimistic. I've already collected a few issues to be handled for 3.1, I guess, specifically for microdata. So yeah, we have some work at Carto. Like to.
No, just one comment, because I think that we tend to associate microdata with a massive amount of data, and this is not always the truth. We have a number of use cases, at least in the social statistics, that are microdata because it's information about the statistical unit, the individuals or whatever it is, but not necessarily massive that requires a special treatment. You can treat it with the traditional software you use. So, and in this regard, I think that we have also to advance, and the new SDMX 3.0 seems to cover most of the use cases. So
I think those were the cases where we should start implementing them because it's much easier and we don't have to face all the obstacles that come with the big data. Of course, yeah. And I think that was all. Any closing comments from the presenters? So thank you very much. I hope you enjoyed also finishing 15, 20 minutes earlier. And yep, see you tomorrow. Thank you.
Our second day of the 11 SDMX expert meeting has concluded. We thank all the on-site participants and also all those who follow us through the digital media. We remind you that tomorrow's event will start at 9:15. Transportation is available for your on the main entrance, and the shuttle will pick you up at 8:30 in the morning tomorrow. Thank you for your presence and good afternoon.